Hello, hello, hello. Praise be the Spiral. Happy Saturday, everybody. Hope you're doing well. I got all my drinks lined up. Feeling good. I'm underwater. Yes, I am. I see. I noticed my camera cuts off at the side, so I've got no arms. Look, it's because I had to make it fit the thing. I've also shrunk myself down ever so slightly so that you can see more of the background. So, um, praise be the Spiral. Yes, indeed. Hey, everybody. Okay, so I'm a squid. Yeah, so as you can see, I've added a little timer up here. You can only guess when a background, you can only change the background when that timer reaches 0. Um, if you make a guess before then, it won't register it at all. It won't tell you if it was there or not. It won't give you any sign that that was a valid background or not. So you have to make sure to check the timer before you try and go for the background. I've also added about another 30 or so backgrounds, and I've set a server up now as well. I'll just quickly show you this. So just got a basic node server. It's kind of hard to see actually on that. That just lists all the searches that you guys do. So um, although that's giving you a clue, I shouldn't show you that because that only shows the ones that don't exist already. So um, that you've searched for. So there you go. Yeah, I think that's all I did today on that. Yeah, no, I didn't do very much. I just wanted to add that in and just make it a bit easier for me to log um, which things you guys search for. Oh, wine or beer? Thank you very much for the bits. I'm on today. I'm on cider again and Kraken. So I'm drinking the rest of my Kraken with cola today because there was something about the Fanta yesterday. It tasted nice, but it just looked gross. This looks like a drink now, whereas yesterday it looked like dirty paintbrush water. Okay, so I'll just explain what we're going to do tonight, and then I'll give you all your points and start the quizzes for you. So I was originally going to do half the night on tutorials, and half the night. Sorry, one sec, and half the night on Perseus, but I changed my mind, and now I'm going to go just for one sec. I'm just going to go fully. Do you want the tunes a little lower? Yeah, sure. I turned them up because somebody said they were quiet in the intro. So, um, yeah. So, I'm gonna do the whole night on Mega65 stuff because there's no real rush at the moment for Perseus. I'm kind of going quite well with that. I think that's kind of okay where it's at so far. I think the collision stuff came together all right in the end last night. So I'm happy to just kind of push it to one side for tonight. I've got the whole week off next week, so I can do some stuff um, next week to kind of catch up with that a little bit. I was going to announce something tonight, but it's well, I mean, it's probably no secret anyway. But it's been delayed a little bit for technical reasons, so hopefully it will be in the week sometime. Possibly Tuesday, possibly Wednesday. I don't know yet. So I'll reveal that a bit. It's not hair. I don't want a hair transplant. I'm happy with this. I'm happy with this. I fully embrace my baldness. I don't care. um, yeah. So 2000 NK for the suggestion. um, yeah. So we're going to do Mega65 stuff tonight. So what I thought we'd do is we'll create a new starting point for our program. So we'll back this one up as I'll call this demo one. Actually, let's rename it. And I'll commit these all to the repo after the stream. And what we'll do is we'll create a new main file. And what we're going to do tonight is we're gonna try and make something practical, something that actually does them. Because last time it was just really a demo, but we'll go through a kind of practical kind of game, I guess. I mean, it probably won't be a game, but we can see what we can pull together in what 5 hours on the Mega 65. We'll do it purely on the emulator, so everybody using the emulator will be able to use this file as well. I'll try and use the macros that I've created, and I'll try and explain some of the stuff as we go along as well. Uh, oh, getting the wrong cans, getting the cans mixed up. There you go. Cheers, Skunk Monkey, for the bits. Very much appreciated. Thank you. As I say, all these bits go towards uh, purchasing and building these Mega 65 kind of Nexus A7 units. These two are, as I said on yesterday, this one is Stokers. That'll be going to him next week sometime once I've got it programmed up. And this one is for Proud 7. This will also be shipping out next week. Just need some time to set up the system itself. Wow, is it 20 months? Wow, it is, isn't it? Yeah. Cheers, Amok. Cheers very much for the bits. Very much appreciated. Yeah, and here's to another 20 more. Here's to another 20 more. Right, let me add points to you all. 4 steps has an aneurysm. There we go. And I'll set the quiz off. So I'm going to try and move relatively slowly tonight. I've got some questions from some various users tonight already on Discord. I will try and answer as many of them as I can first, but I'm going to try and do it in a practical way as we go along. So let me. Where's the race? There we go. Oh, thank you very much for the cheers as well, for the bits, AD. Hey, Anton. God damn it, I say that every time, don't I? Can you just change your name to AD? It would just be easier for me, thanks. Getting old, aren't I? That's all it is. Right. See, this is because you rushed the point, so you got a PlayStation game to teach you a lesson. Okay. Oh my god. Oh my god, stop it, guys. I mean, cheers. Cheers, cheers, cheers. You're gonna get me drunk before I've even written a line of code, because every time you do this, I take a drink. So, oh wow, somebody got a PlayStation SP. Oh, nice, nice. Oh my god. Right, I'm having cider this time though. Thank you, Kenneth Mirror. Very much appreciated. Thank you for the bits. Oh. Right. So what I'm going to try and do tonight is not only go through the kind of setup basics, but some of the did did you just do a random gift sub, Andy? Thank you for the gift sub and congratulations to Shimmerbot. I should see if I can turn down gift subs on oh, you picked the bot. Okay. Okay. Cool. The bot does all right actually. The bot's had quite a few gift subs so far. He's my best mate. uh oh, that's kind of sad. That's kind of sad. I feel sorry for you if he's your best mate. He's my only. Oh. Okay, so what I'm gonna do is oh my god. Oh god. Thank you for the gift subs, Amok, to C64 Mark, Turbo B, Riker 77, Gladius KZCL, and Medov. Seriously, you're all far too generous. Oh my. I'm gonna be so drunk before I start. Oh. Okay, so what we're going to do, we're going to try and use. Actually, do I already have these includes? Maybe I've not put these on my GitHub yet. Let me just check. Not that one. Let me try and find this. I'm pretty sure. Oh yeah, I did. Okay. Okay, so there is another repo which contains one of the. Oh, interesting. Huh. Okay, I just need to check something quickly because. Uh, huh. Oh my god! Thank you, Pro7 for the bits. Thank you, Ducks to Me for the bits as well. Cheers. Oh my god, and Steps as well. Cheers. Okay, so this repo that I've just posted in chat that contains a floppy I/O system. I'll include that and show you how to use that because it's useful to load things into the upper memory. Something you won't be able to do directly with a PRG file. I've just noticed two background requests that do not show, and I think I can see maybe why they don't show. I will say I will say for now, don't put spaces in your requests, um, because I'm just going to show you why in your background request that is. Because that didn't work either. Interesting. Let me just quickly try. I need to make this sure this is working before I continue on. We'll get coding very soon. Uh, Thank you guys so much for all the bits and Quadrasil as well. I missed that one as well. Thank you. Oh my god. Right, I'm gonna try it myself as soon as the time runs out. Yeah, see, there you go. So don't put a space in it. For now, I'll work out why that's not working for the next one. I'm not sure why, uh, but it shouldn't be doing that at all. It should be filtering out. So if you have tried anything with the spaces in, it may have been there. That's fine. It's fine. I'll figure out. I'll figure out why. Um, hey, Zach Specky, welcome. Yeah, I saw you tried with space. That's why. So, you need the Nexus A7 AT100. Sorry, Arctic 7100T. I don't know if you can see that. Oh, it's gonna the green screen's gonna cancel out. There you go. The Nexus A7 100T. And that will give you the ability to run the Mega65 core as close to the hardware as the actual hardware as possible without owning the actual hardware. Um, so if you want to use Attic RAM, you will need the Nexus the Nexus 4, I think it's called. This one. Yeah, Nexus 4, which is this one. Also at A100T. But the Nexus 4 is the only one that you can use the Atagram on, just so you know. Or you can just enter the competitions and you may win one. So this month he's making a game, uh, and it's a prize draw entry as well. So it's not a judged competition. It's just if you make a game, you enter the competition, and you are in with a chance to win one of these boards. Okay, right. Let's crack on because we've not actually done anything yet. Because of all the hype. Ah, oh, I thought someone had typed that. Okay, I keep getting weird kind of patterns over on that side. I don't know why. Uh, it seems to be very fussy with the lighting. So occasionally I may have some stuff over there. I don't know why. It's usually to do with the colors coming off the screen, but I don't know why that's doing it now. Okay, let's begin. Oh, and I got a hype train as well. Thank you very much. Okay, so we'll start the same way as before. We're going to set the CPU up and we're going to import this, and then we'll go and change the. Well, we won't change it, but we'll keep the make file open because we're going to add some stuff to this as we go. So this deploy here is for. In fact, can I put a note in above it? Yeah, let's put a note in. So over serial port to Mega65 or Nexus boards. This is our assemble. But what we're also gonna do now is we're gonna change this to instead of using a PRG, we're gonna use a D81 file. So we'll do that first. I have already got this in the Turrican make file, so I'll just grab it from there. And the easiest way to do this is with these two commands, write and format. Is it these ones? Yeah, write and format. So write and format require the C1541 file, which you can find in Vice. If you're using something other than Windows, you will want to change this. So I'll just put this here, 1541.exe from Vice, used to create a D81 and add files. So this is quite important to have if you want to have your pipeline kind of build disks as well. So I put that in there, and then the format's really, really easy. We basically just do this. So we format the disk first. Oh my god! Oh, wow. Okay, excuse me. Not fair. This isn't Mac format. Yeah, you will have to kind of adapt it for Mac format. I think if you're working on Mac, you deserve to have to convert things. And if you're working on Linux, you probably have the opinion that converting things is the most fun in the world anyway. So, where's my pen? I had it somewhere. Um, you'll find it easy anyway if you work on it. And you should find it easy on Mac as well. I mean, these aren't complicated files; these are just aliases and things. But if you do create one, please feel free to send it to me. I can add it to the file, the folder as well, so it's there for both. Yeah, yeah, I just answered your thing. Yeah, yeah, I was just answering you directly. You're far too easy on the listen button, aren't you? Okay, so we're going to create this. We're going to call it main, and then all we have to do is we say this is what it's going to be called on the disk. So this formats the disk. This creates a D81. This writes an entry to the disk. So this will create a PRG entry. and it on the disk, and it will put this file in it, and it will call it main. So when we do a directory, we'll see that. Then we just need to launch that disk. Now I can't remember how to do this actually on XEMU. Let me just have a look. CLI. Let's have a look in the repo for this. We'll just set this up really quickly, and then once we've got this set up, we can very easily kind of load things into various locations. And the reason I want to do this is because I want to show you. How do I search on it? I want to show you how to use my floppy loader to load various things in. Here we go. I think this has got a list of all the different commands. I think it's probably just D81, but I'm not sure. Well, let's just try it. Let's try D81. And it's just called, at the moment, it's just called disk.d81. You can change the name of it up here, but let's try it. Okay, so if we just try that and run it, we'll have to put some basic program in here. So let's create the basic upstart. So first of all, let me just explain about the basic upstart. Thank you for the hosting now. Oh, also thank you for the hosts. I think it was Prow7 and Andy Magic Knight. I missed before the stream. So much has changed in the past. There we go. Andy Magic Knight and Prow7. Yeah, thank you guys. Support for Mega65. Yeah, no, so lots of config files. The batch file is missing a dot before bin. Let me check. Thank you. Thank you very much, Bitrend. I'm going to give you 5 AMK points for that. There you go. Okay, cool. Obviously, we don't need this deploy. This is just going to launch XEMU with disk image. So we're just going to create an entry file here. All I'm going to do is turn the interrupts off, increase, actually, I'm going to do, oh, we don't actually call those, oh, setup system. Okay, yeah, we do these here. So I want to check these as well, because phase 101 was saying that these are not necessarily setting the frequency correctly. So we'll check that as well in a minute. So this is just our basic program here. Which hopefully should build place the okay. I have placed that file there. There we go. Oh no, an option D81. Okay, right. So I need to figure out what that option is. Let me find it in here. 8. Okay, it's just -8. Oh, there we go. We're loading, and now it's loaded the disk. It hasn't auto run it though, so I wonder if there's an auto. Otherwise, you can do. Well, if we do DIO, we should be able to. There, you can see it's there. Okay, it's not increasing, but it is running at 40 megahertz. So we can see that. We can see in the just get this a bit bigger for you guys. There you go. So it is running at 40 megahertz. I'm not sure why it wasn't before. And it's also not increasing the border. So let's just check. Probably need to disable some other things as well. So I think what I probably need to do is that. So I think you still need to use the banking because if you don't use the banking, the C65 ROM kind of overlaps ISS, that would be a good one, wouldn't it? Yeah. I'm glad I'm recording all of these. So okay, I'd like that to auto load. So is there an auto load? Auto load. There we go. So if we just put -auto load, try it again. Hopefully, it should run automatically now. I'm not sure what that did, but it wasn't right. Okay, I'm a bit annoyed this isn't working. I haven't had to deal very much with the emulator, so you bear with me while we deal with this. I would have thought it auto loaded, but apparently not. Auto load. It just says. Where's it gone again? I've lost it now. Load and start the first program from disk with auto typing can be okay, so this is supposedly supposed to be auto. This has failed for some reason. That's supposed to be that, I think, or something. Let's try again. Maybe it's running too fast or something. Yeah, the auto load is failing. It's failing to do the load here. This has been annoying. Oh, okay. Oh, damn it. Gotta figure out where it is. There we go. Okay, it's not advancing the button. That's bothering me actually now. Why this isn't working? Why is it getting stuck here? Okay, let's go through the full list of things I normally do. So let's actually just copy this entire function. So we'll have a setup system function again, like normal. Interrupts, yeah, that's what I think it is as well. If this works, then it is interrupts, then you get another 5 for saying it. Even though I was doing it anyway, but oops. So we're going to use this to set all the mapping and stuff. So the mapping. This is one of the questions I had before. So there's 3 sort of mappings going on here. This one is ensuring that the IR. This is exactly like the C64 one. I'm not entirely sure which areas of memory it deals with because the kernel is not quite the same. It's using the C65 ROM down here, but I do this anyway as habit, and it makes sure I have that area of memory freed up. Then there's this, which is kind of a mapping instruction as well. It's not really a mapping instruction in that it isn't technically uh, it isn't technically mapping anything. Well, no, that's not true. Actually, it is mapping the VIC4 registers into D000, but it's not really. It's not really changing anything in that area. It's just making sure that when you access that area, it's the VIC4 registers that are there. And then the final one is this, which again isn't really a map. This is just making the this area here 20,000 to 3FFF writable. So this is where the C65 ROM is, and if you don't do this, you won't be able to write over this. So, hey, Daycore29, welcome. Hope you're doing well. Can't say too many words down here. Right. So let's try again. Hopefully that will work. And now we've got this built into a disk and running from a disk, although it's not properly running from a disk, which is a bit frustrating. So it yeah, there we go. It's working now. It's only running at 3.5 megahertz though now, so I'm not sure why that is the case. So let's do these instead at the end down here. See if that makes a difference. This was the problem that FaZe was on about. Yeah, let me give Andy some points. Oh my god, Andy in the listen. Okay, I'm gonna nerf that. I'm gonna nerf that. Okay, so that actually breaks it when I do that, but it keeps the 40 megahertz range. Okay, so let's try enabling the VIC4 here and do the 40 megahertz last. Oh god, that load is annoying. I am probably going to turn that off in a minute. So I kind of can't because I kind of want to. Oh god. Oh my god, that doesn't work either. What is breaking here? Something is breaking. If I enable 40 megahertz last, it breaks. Uh, hmm. And see, this is definitely an emulator thing. So let me just turn on the real Mega65. Show you what I mean. This is definitely an emulator thing. So if I do this instead, just get rid of that. So there's definitely an issue. Um, the border changes look different. Or the reason the border changes look different is because the emulator doesn't update multiple times on a scan line. It only updates once per. There we go. It's one for the Warcraft fans. It only updates once per scan line, so you get a very different kind of raster effect. Okay, so this means we need to be careful about how we set this up. So let's try and figure out the correct setup for this, for the emulator. It really shouldn't matter, but for some reason it does. So I'm just going to try and enable that maybe after the Bit4 registers instead of before. Let's change this temporarily. We'll come back to the disk image when we actually need it. But for now, we'll do with PRG. There we go. Yeah, there we go. That's working, but it's still no, it's still working at 3.5 megahertz. I do not know why either. Yeah, I mean that's exactly what this is doing here. That's exactly what this macro is doing. I mean, if I try and I mean, it should be exactly the same. If I look in the macros in here, it's exactly what it's doing here. But I mean, let's try it out. Oh, well done. Steps found a new background. Go Helsinki for anybody recognizes that. Oh, Acmafin, it wasn't steps. I saw the steps redeemed and we tried for yeah, I did try it before. See, it breaks when I do it there. I think it was originally before it. Let's try again though. I'm going to move it around. There's going to be a place where it works. The problem is I think it works in this location, but it doesn't actually set 40 megahertz. Yes, it's still on 3.5 megahertz here. Yeah, so let's move these around a little bit. Let's see if we can figure out what's going on. No, it's still 3.5. Something changes around here. So let's see where it is that it breaks. Does it need an interrupt? No. Well, I mean, it doesn't on the real system. The real system, you know, works absolutely fine. So, um, yeah, let's put it before. Let's try it. Oh, maybe yeah, maybe the hot registers. Am I actually doing that? I'm not, am I? Okay. Hot registers. Okay, so this is let me find an example of this. Oh my god. Am I doing this in the demo? I think I might be in the demo. I keep scratching my eye, and I've had chili tonight, and that's not a good thing to do. Okay, I'm not doing it in here. Oh yeah, I do. Okay. So hot registers is just a way to ensure that if you change certain registers, VIC2 registers, it doesn't destroy other things. Should be before the disabling of hot registers. Yeah, which it is there. Let's disable the hot registers here. Put that there. So what this does is means if you change anything in the VIC2 registers, like we are doing here, for instance, this won't destroy any of the VIC4 values. Now, I wouldn't expect this to have an effect, but maybe it does on the emulator for some reason. No, see, still 3.5 megahertz. I do not know why, but I cannot get it to do 40 megahertz. So the code is simply that. It's just poking 0 with 65. That's all it's doing. I do have a set interrupt. I have a clear interrupt at the bottom. Oh, what's that doing though? That's not. You shouldn't need to do that for whatever D031 is. Let me have a check. That is. Well, it's not even in there. So it says C65 register. C0. Oh, okay. So it's setting a fast flag in D061. Okay, so let's try that. I'll do it in here then. So I'm going to change this macro. I will update this macro with the same thing. I'm just going to turn on that one bit, not all of them. If that's the solution, Mythical Duck, then you get at least 10 points for that. But alas, it is not. It is the same. Yeah, I'm not sure I'm not sure that is needed because I definitely don't do that in anything on the real device. So I'm not sure why that's not running at 40 megahertz. Let me just check what that's actually supposed to do. Enable C65 fast mode, 3.5 megahertz. Okay. I don't know what is going on here at all. Let's get rid of that. Maybe disabling the ROM for some reason. Maybe that hypervisor call does something. Nope, actually breaks things. You had 40 not C0. Yeah, because the 80 part of that is just set in 640 640 wide, horizontal 640 mode, which we don't need. I'll try it with C0, but I don't think it's going to make any difference. If it does, that's really weird. No, it doesn't. 3.5, see, same. So I'm actually going to remove that because I don't think it's required. Why is it not working? Okay, so that's the fine. How come you weren't? How come you weren't? Oh, store a key. I was using set bit, so instead of storing, I'm just setting a bit. That way, I don't destroy anything that might be happening in the bottom half of it. I mean, I'll try it with store as well. But again, I don't think it's going to make any difference. And the problem with that is it will override anything you already have in that location. So yeah, exactly the same. So yeah, I'm just going to remove that. I don't think that is relevant at all. Let's try Andy's suggestion. No, same. See, the problem is this, right? If I don't do some of this, then it's fine. Let's work out which bit, if I don't do, it works. So let's just turn them all off. This means that the The loop is not going to work, but we're now running at 40 megahertz. Now let's turn the raster interrupts off as well. Okay, so the raster interrupts is not enough. It's the CIA interrupts as well, probably, that's the problem. What? Oh, wait, hang on. That's the wrong way around for a start. That should be like that. Still the same. Now, I don't know why not turning off the C65 ROM causes a problem. It really shouldn't. Yeah, I've tried that. I've tried that all the way up here. All the way up here, and it doesn't make any difference. No difference at all. Um, yeah, and it does work. If I turn all of this off, you can see it's running at 40 megahertz now. You can barely see it, but it is running at 40 megahertz up there. This is really frustrating. It's frustrating because this absolutely works 100% on the real machine. So, um, what controls the chip seed? There is a special value in memory that you knock um, with values for it. So let me try doing it twice. Maybe it's something stupid like that. No, I see. It just breaks the moment I call it again. It just breaks. Oh, I mean physically? I have no idea. I have no idea. Um, I suspect that it's broken in the emulator for some reason. Let me try and get in the latest version of the emulator. Maybe it's something that's been fixed, and I've just not realized. Uh, but I definitely. I mean, I don't know what more I can do because this is working on the real machine. So I've got to get to a point where I say, okay, I can't kind of do too much if it's not working on the real. If it's so different to the real machine, then there's obviously something else at play here. So, where's the actual downloads for this? I thought that was the downloads page, but it's not. Oh my god. There we go, download page. So I know there's one at the bottom here. I don't know how old this is, so guess we'll see with the dates. Oh, okay. This is fairly recent. So let's go and take a look. Let's just grab all of those, place them all. Let's try again. It's going to be one of those. Well, the thing is, I'm not gonna spend too long doing this, but it's working for me. But first thing I have to start. But are you doing all of this? This is the thing. Are you turning off interrupts? Are you doing? Is this as soon as I disable this ROM, it breaks. So let me just get rid of all of this stuff. Let me just break it down to the basics, and we'll just add things in slowly as we go. So I'm not going to disable interrupts. I'm not going to do any of this. I'm not going to do any of this or this. I'm just going to disable interrupts. Then, well, no, I'm not even going to do that. I'm just going to return. And so this won't do anything, right? We should see this fail because the ink D020 is not pointing to the right location. So that's normal, right? If I enable the VIC4 registers, we see this, and then we get a break, and we get a break because the interrupts are enabled. So if we disable the interrupts, so we have to first of all disable them here. Let's just disable and leave them disabled. Let's not even bother with setting the other thing. Okay, there we go. So we've got it running now. But that's because we've completely disabled the interrupts here. We never re-enable them again. So now let's do it this way. So this should give us the same result. There we go. Yeah, and you do need to remove the space as well from the guesses. Unfortunately, the one thing I forgot to check today was things with spaces in it. So we'll figure it out. PC not strong. Oh god, it is definitely powerful enough. Come on. And I think you know this. Right, let's enable 40 megahertz now and VIC4 registers and do nothing else. See, we're running at 40 megahertz, but now we're failing. We failed to do anything else at this point. And this is what's bothering me. There's something about enabling 40 megahertz which just breaks the emulator for some reason. So let's try doing it when we're out of the interrupts. So when the interrupts are re-enabled again. Nope. Okay, let's try incrementing the border, then doing it and just trying it over and over again. Okay. I can't explain why that worked, but it did. So the question is, why did that work? So let's try putting it in here and putting some knobs before it. No. Okay, let's try huge, well, not huge delay, but a delay of some kind. Okay, it's running at 40 megahertz, but it's not doing our border changes. Switching to 40 megahertz in the middle of an interrupt, but this code shouldn't run. If the interrupts are disabled, let's try. Yeah, let's try not doing that and just disabling them there instead. So let's try that. No, same problem. It's a bug. It's a bug. It's definitely a bug because this is absolutely working fine in the real machine. So I just wish I could explain why, but I don't think there's an awful lot I can do about it. And the thing is, I don't want to spend all freaking night sorting out an emulator bug. I really don't. That's a massive waste of our time. So, um, uh, before first thing after set up system, yeah, I've tried it there as well. Same problem. It will either run running 3.5 megahertz um, or 40 megahertz, but not show the border change. The border change stops at that point. So something about doing it in the wrong place causes a problem. But if I put that in the loop, then it suddenly works. That's what's weird about it, right? It's almost as if the first few times you do it, it doesn't work, and you have to keep bashing it until it works. So I mean, if I did this, right? So if I do so it's going to do this 255 times first, and it still doesn't work. What if it's cycling around the BG colors each line? I mean, that's a good point. That's a possibility, because of the way that the emulator works. So it's a very good point, actually. Let's try that out. So instead of doing, let's put it all back and let's have a look, right? But the problem is when we do this, we get 3.5 megahertz, right? So that, oh no, we've got 40 now. Okay, we've got 40 megahertz. So let's go and change this. Let's put some knobs in here. Same thing. So let's do something huge in here instead. Let's just call it L. Now I don't know what to think. Now I don't know what to think. What the hell? I can't explain that. I really can't explain that. I think it is a bug. I think Sharatz is on the right lines there. I think it probably is because the way the emulator works, it can only change the VIC issues. It can only change the VIC properties once per scan line, and it could just be that the timing is so kind of tight, so kind of wonky or whatever that it just happens to be picking the same value all the time. It seems odd though that it would do that so much, and only when I start doing this does it change. Um, it does sound very unlikely, doesn't it? That's the thing. But see, look, now when I'm just doing one little delay in here. So this is what? This is 2 cycles, 2 cycles, 2 cycles. So this is 3 knobs, right? So that's the equivalent of doing this in terms of cycles. It's the Hernan branch, yeah. It's the Vic 4 branch. It should be the one that works. Uh, so 3 knobs works. 2 knobs does not work. Okay, very interesting. All right. Okay, well let's move on under the assumption that it is kind of running at 40 megahertz. Uh, EOM is just NOP. EOM is just the same as NOP. It's the same command pretty much. It's the same. It's the same value. It's still EA. It's just in certain places it's used as an end of map. So if you've used map and then use a NOP, then the NOP becomes an end of map. Okay, so let's this is annoying. We've spent an hour doing this now. Right, so this is running at 40 megahertz. Right. Let's turn off those interrupts, the hot registers, the memory layout, set that up. Okay. 40 megahertz, with a different color border, but yeah. Can I just do the NOPs after the setup? Very good point. Let's try that. 3 NOPs seem to do it. No, they need to be in the loop. Okay, let's go under the assumption that the very weird, unlikely case that the increment is just synced perfectly. with the board. There are no bad lines on the Mega 65, so this could actually be the case. It seems very unlikely, but at the same time, I don't have another explanation for it, so it's unfortunately the only explanation we've got. LGB will pop by. Okay, cool. I think it's probably just a syncing issue. I think Sharatz is right, so we'll demonstrate it to LGB when he appears. But let's for now, let's just carry on. Uh, and see what we can do. Okay, everything else seems to be fine. All right, I forgot where I was at now. What were we doing? Try ink screen ramp. That's not a bad idea, actually. Yeah, let's try that. Let's try 0800 and see what we see there instead. As long as that's kind of cycling round, then we know it's right. Okay, yeah, that is cycling round. It does seem to be cycling between the same few values, but it is actually working. So it is moving. If I did that at the same time, I mean, obviously it's only going to update when the scan line goes past it. So yeah, I just think it's a timing issue. I think it's a timing issue because of the way that the scan line works. So Sig Packet Math says it's 512 color changes per line, which would be spot on, right? Which would be exactly why that happens. Um, yeah, and if you would change that down to 3.5, that means you've got you're dividing it by like 12 and a half or something, so you definitely get a different value. So yeah, okay, I think that yeah, that kind of makes sense. Okay, well, I don't think we need LGB, but we can get him to confirm what we found here. But interesting nonetheless. So just be aware of that. As I say, this is what it looks like when it's running on the real machine, and you can see it's changing several times per line. So you see the entire kind of color palette as we go through it. But obviously on the emulator, we don't have that kind of cycle accuracy yet. So while it is running the right number of cycles per frame, it's unfortunately not updating the VIC as often as the real machine is doing. So we don't get that same thing. You have to bear that in mind when you write stuff as well for XEMU. Okay, I mean this is as much a learning experience for me as anything else. Uh, yeah, the real machine does show some drift as well. Yeah, you're right. Um, yeah, that's a really good point, isn't it? It's not like the colors are the same at the beginning of each line, so there's definitely not cycle accurate then either. So uh, yeah, that's what we're kind of thinking LGB. So for scanline, do scanline Vic 4, even a fast PC would not be enough. Mega65 is too complex. So the cycle count is multiple for CPUs per scanline. There's some static pattern, I guess. Well, it's not so much that there's a static pattern. So you can see if you just look down or down there, that's the real Mega65 dev kit down there. That's just running this Inc D020 after kind of enabling VIC4 registers and disabling interrupts and stuff and enabling 40 megahertz mode. But when we run this on the emulator, what we get is no color change whatsoever. And at first, I just thought, oh, there's a bug somewhere in this. But then we noticed if you just kind of screw the timing up for the line, so it takes a little bit longer. 3 knots is what is enough to do it. Um, then you do start getting the pattern. And I mean, I can tell, you can see with the fact that the lines are the same color all the way along that it is doing one Vic update per scan line. That's fine. But I think that's all it is. I think it's just that as Andy Magic Knight said, his kind of back of a fag packet maths shows that this is actually running 512 color changes per scan line, which would be enough to exactly keep the color the same all the way through. We were just discussing the fact that on the real machine there is a drift, so there is a cycle drift. So it's not doing exactly 512 color changes per line; it's doing a little more or a little less. So Uh, I couldn't use that word thanks Twitch. Oh, cigarette packet. Yeah. Yeah. But yeah, yeah. Yeah, no, that's absolutely fine. I just wanted to try and understand what was going on. I thought we had an emulator bug, but it's not a bug. It's just kind of a limitation at the moment. So that's absolutely fine. But welcome as well. Welcome to the stream, LGB. All right, let's carry on then. Let's just go under the assumption that everything is working. It's just a visual thing that we're not able to see that increment. If we just do it like that, we'd need some other stuff in there as well. And indeed, if we just increment the screen address at the top corner, we can see that works absolutely fine. Thanks. You feel welcome now. You're very welcome at any time. So you can see now we're doing a bit more on the line. Um, it is alternating between two colors instead now, and we've actually got something happening in the top corner. But yes, thank you very much, LGB. Thank you for the fast response as well. Um, okay, cool. Let's move on to the next topic then. So I've just looked at the backgrounds. You guys have been requesting some good ones in there. Actually, I shall be looking into those. Have I got some hair in there? There we go. So there was a couple of questions around. Uh, oh, DMAs is one. Let's move on to DMAs. So one of the things you're going to want to do quite often is fill the screen uh, or clear the screen. Clearing the screen is essentially just filling the screen anyway, right? So one of the things you might want to do is clear the screen. Let's keep the screen at 0800 for now. Actually, no. Let's move the screen. Let's move the screen up into the upper area. So let's create a label for where the screen RAM is. Let's move it all the way up to here. It's good to have things in the VIC in this area of memory. The reason being is because you can't use this area for code, so it's good to kind of use that stuff for VIC. It's perfectly usable by the VIC. So it's good to put all your sprites, your characters up there. Any data structures, basically anything that's not runnable code, keep it up there and out of the way. And then that way you've got more of the 64 kilobytes in the first 64 kilobytes of memory free to do what you want with. So let's just get rid of these things. This is just a loop at the moment. Let's just leave that there. Um, uh, let's just call it setup M65 system. So it's obvious that what we're actually doing there. As I say, I'll share all this code as well at the end. It's quite basic, but hopefully it will give you some starting points for doing things. So let's oops. Let's create another routine. Let's call it setup Vic. Or setup screen, let's call it. So it's a bit more focused. Oh no, let's call it setup Vic because we might want to change the character sets and things like that. So let's do it here. Okay, so I just got to keep an eye on my messages in case I get an important message. Okay, so what we're going to do, we're going to move the screen. I can never remember this off by heart since D060. I will learn this eventually. Yeah, D060 screen pointer. Okay. So we're going to first of all, we're going to relocate the screen. So this is one of the nice features of the Mega65. We can move the screen any way we want. We can also do the same with the color RAM. We can also do the same with the character set. But most of you will probably find that using the full color character mode is best. And if you use full color character mode, you don't need to relocate the character set at all. The entire 384 kilobytes of RAM is usable for. is I like that background. The entire 4 kilobytes of 384 kilobytes of RAM is available for VIC4 stuff. So cheers and cheers. It's a good one, isn't it? That I like that background. some comic. Okay, so we're going to relocate the screen. So again, I do think I need to contact. Maybe Jesper can do this actually because he's got his own branch of this. I'm using his branch at Kick Assembler um, to create this. I'll show you when I get to it. So what we're going to do is we're going to change three values of screen, and the very upper byte doesn't matter. It's usually 0 anyway. You could set it if you want to, but it shares the memory address with a few other things as well. I think by default it's 0. So D063 you should need to mess with. Um, but we'll set the LSB, which is why we use this. MSB, which is why we use this, and then the 24-bit MSB, I guess I'd call it. I don't know what I'd call that. I think it should be that, which is I think what Acme uses. But unfortunately, it's not available. So what we have to do is we have to do this kind of manually ourselves. We need to take the screen RAM address, which is this address here. We need to shift it 16 to the right, and then just AND it with FF, and that's just going to ensure that we get that 24-bit block of 8 bits anyway. Yeah, I saw that you're in the middle of doing that. I think the thing that the most the kind of the most important thing I think was something Hernan said he was working on at the moment, which I think is the nibble the nibble color mode as well, because I think Magic Eric kind of wants to use that for another world, which would make sense, and I think it would open up a lot more um dev stuff as well. Certainly the libraries I've created for Perseus all use nibble mode because it's just much more memory efficient. So and honestly for most things it's going to be more than enough. Full color mode is kind of overkill for things, really. It's very rare you need to have more than 16 colors in an 8x8 block. Or actually nibble mode it's 16 colors in a 16 by 8 block, but it's rare you need more than that. That's kind of plenty, and it's more than most machines at the time. So it's still very nice. 4 bits per pixel is still damn good, and it does make the raster rewrite stuff really efficient as well, so you can get like loads and loads of layers together when you do that. Okay, so we're setting the screen RAM here, so we're just going to relocate the screen for now. We'll add some more stuff into this in a minute. So we've relocated the screen, and if we want to clear the screen, we'll just create a clear screen function, or we'll call it fill screen actually. And what we'll do is we'll pass a value in. So we're going to pass in 20, which is our empty one. I will separate these out into separate files shortly as well. I won't just keep piling them all into here. Let's make it a nice browsable project. But for now, let's just pile them in, and we'll split them all up at the end. Okay, so there's a few ways to do the full screen. One way would be to use the 32-bit addressing mode that we talked about, and use a 0-page address to store the value there, and cycle through the screen that way. This is kind of the traditional way you would do a clear screen on the C64. You wouldn't use an indirect mode. The only reason we need to use this indirect mode is because our screen is up in the upper area of memory, so it's beyond the 64 kilobytes, which you can address with normal 16-bit addressing modes. So you need this 32-bit addressing mode. Another way to do it would be to map this memory into a location in the lower 64 kilobytes, and then use a traditional screen clear. So the way you would do that with the macro systems, this is already should be in here somewhere. So you've got this here, map memory macro. You can read through this and try and understand it. It is documented in the manual. It is a little bit complicated. I don't know if this will work on the emulator. I assume it will do. I mean, it's well, we can try it out if you want. Let's try it. Let me just do an RTS here so we can see what the basic screen is like first, and we'll see if we change it. So this is what it looks like. So this is the data that's up at that area in memory, up at 10,000. Would load accumulator screen rem plus 2 work too? Uh, no. No, 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 because that will take, so what that will do is that will take this value, it will add 2 to it, so it becomes that, and then it will take the MSB of that. And because it's this is the LSB, this is the MSB, and this is the bit that we can't access. So no, that wouldn't work, unfortunately. So what we need to do is we need to take this value and we need to break it down into the 3 components: the LSB, the MSB, and the 24-bit MSB as well. Okay, so you can see that there was some junk on that screen. So let's just try it. Let's run it again. What we're going to try and do is we're going to try and change this character up here. So you see how it's a little. You can't see it. Let me make it bigger. You see how it's a little red square. We're going to change that to something else, and we're going to try and do that using the map memory function. So this is a macro I've written. It will take a source address like so, and it will map it to a low address somewhere. I do not recommend you do this at all. This is, I just want to demonstrate what this function does. Evening, Thalamus, welcome. So this macro will basically map this memory to live at this address. So now I can access this address. Um, let's put an at symbol there, and it should treat that address as if it's this address here. And you see there it has indeed mapped it. I definitely do not recommend using this method. You see, it was a red square and now it's this at symbol. I definitely do not recommend using this method for this sort of thing. Its best use really is for running additional code. So, say you had some, you put some code uh, here like this, and you did something like that. Now, you wouldn't be able to run this code because it's not in the upper 64 kilobytes. It's not in the lower 64 kilobytes. So what you can do instead is you can map it temporarily, and it won't delete what's at this location. It will just, much like 64 ROM RAM mapping. Why show something we shouldn't do? That's reckless. I'm just demonstrating that you can map this memory. So now I can do that, and that will map that memory. So this allows you to have more code than oh, it's not going to allow me to do it because okay. So this is one of the things with the emulators. You can't load stuff in beyond the 64 kilobyte limit, but if you could, that's how would do it. This is why we need the floppy IO registers, and I'll go through them at some point, but not now. So that's another way to do it. Again, like I say, you probably wouldn't want to do it that way. But the easiest and by far the fastest way to do this is with DMA. So DMA is a system that allows you to copy memory from one location to another using. Yeah, I'm on a green screen. You can guess the backgrounds now. We've got a whole background thing going on. Who guessed that one? SP, cool. Aha, la, la, fancy. Yeah, it's fucking massive as well. It's bloody huge, but it's cool. I just wanted to give something back to the stream now and again with some fancy stuff because there weren't enough quizzes. Yeah, exactly. um, yeah, so DMA lets you copy something from one area of memory to another area of memory. The great thing about it is it can access pretty much all of memory. There is no limit to where it can copy to and from. And the other advantage of it is it uses a separate chip as well. So while it does hold the main process while it performs the DMA, the chip that actually does the DMA is much faster than the 45GSO2. I think it copies at 20 megabytes per second, so it's quite a lot. So it's very good for doing um, these kind of fills and copies. So it can do copying, but it also can do fill as well, and it can also do merging as well. So I use it in the Turrican demo for the waterfalls. So all the data in the waterfalls is just a full color character mode. So it's 64 bytes per character, and then it's in a grid of like 4 by 4 characters. So it's about 1024 bytes, and I just shuffle them down every frame, and I use DMA to do that, and it makes it very, very quick. I also use DMA to create the splash at the bottom. So even though the waterfall is moving down and the animation of the waterfall is changing all the time, the splash is overlaid over the top of it, and that's done using DMA with transparency, which means it will only copy a byte to a location if it meets a certain criteria, which is that the target location is transparent, um, or the source is transparent. Sorry, not transparent. So we can use DMA to fill the screen, and luckily we've got DMA built into these macros as well. So I'll show you how to do these now. So just remember exactly how to do this. Where's the fill job? There's no fill job in here. Oh god, I'm gonna have to create a fill job. Okay, that's fine. That's fine. Let's create a fill job quickly. I'll do this quickly, and then I'll explain how this works. Uh, Fills, copy and chain. Okay, so this, if you're interested in what DMA, how the DMA works, or the very basics of it anyway, the C65 manual, which I'll link in a second, if I can find it. C65, is in that one? Yeah, yeah, it is this one. All right. So this is on Zimmers. Yeah, if the timer is running up there, then you won't. The guesses will just be ignored, whether you're right or wrong. Um, I like it when Thalamus comes on because he always plays the good Steve Rowland stuff. So, although is this a remix of it or something? Oh no, this is one of the Retrograde things. Okay, I'm not so familiar with the Retrograde stuff. I'll go through that in a minute, Amok. I'll just get the DMA in, and then I'll explain. I'll explain the character mode, and because I kind of have to explain it to see why we need to fill it so much. So that link has all the C65 stuff, and the Mega 65 is just a C65. So um, one thing it does contain is the DMA magic stuff. So if I search through here for DMA magic, I should be able to find. So DMA magic is the chip that performs the DMA stuff, and in here it should tell me exactly how to do the fill. So fill is one. Okay, let me just check operations. Where's that? There. Okay, so 3 is, so this would be in a, that's a copy job, it's a mixed job. Okay, so let's call it fill job. And don't worry what these bytes are for. You can read the manual for these, but these are just determining that it's a fill rather than a copy. Source byte is just a single value. Backwards is not important on this one. Go. And source would be that, I think. I think that's right. Well, we'll test it out now anyway. So the way DMA works is you have a kind of an instruction list, and then you have some functions which call those instruction lists. So the macro that calls the instruction list is called run DMA job. So we'll just drop that into our code, and you point it to a job. So we're going to call it fill screen job. And fill screen job is just going to be a memory location here, and this is where we actually add our extra data in. So we need to start with a header. And the header basically just tells it which banks we're working on. So this is this is the megabyte banks. These are both going to be zero. It's very rare you're going to use anything other than zero unless you're working with floppy sector copying, which you shouldn't need to do because I've got that covered in the floppy IO stuff. So you just create a DMA header with 00 in it there, and then you just say we want a fill job. Our source byte is going to be 20. Actually, we need to pass this in, so we might actually have to do this manually. Let's just call this clear screen for now. And we won't pass a value in. We'll just automatically clear it. So this is what we want to clear it with. The destination here is going to be screen RAM. The length is going to be, so however big our thing is, and this will be false. With chain means, do we need another job straight after? We don't. So creatures two intros out. Maybe it was it's probably a weird yeah, worst, yeah, best match, yeah. It can be a bit funky at times. Sometimes you just have to type the artist name in as well. It's probably the best way to do it. So the length is going to be how many bytes we want to fill in. So with the basic screen, we're not in any special mode here. Every screen location on the screen is just a single byte at the moment. So we just need to fill 1 byte per screen location. The default mode is 80 columns and 25 rows. So it's 80 by 25. This is the default that you come into. Is there more than one DMA? There's a few different types of jobs that you can run. But what do you mean more than one DMA? You mean more than one DMA type, or there are 2 job types, but there's no there's only one DMA chip, so it's only going to do so it's only going to do these one at a time. It's, you can't kind of see, you can't like run these in parallel or anything. As for types, there's the old type of DMA and the new type. The system I use uses the new type all the time. It's called F018 and FA and F018B. Um, again, read the manual if you want some information on that, the C65 manual that I linked. That's probably the best place to get this information, or in the or the Mega65 manual. It's a bit too much to go into on stream right now, but it is very powerful, and there's quite a few options in there now as well. But you have different job types as well. So as well as DMA types, you have job types. You have fill job, you have copy job, and you have mix job. Mix job is just a copy with a I think it's a copy with a transparency thing as well. Mix a chain. Yeah, it's just using copy here. Actually, I don't think this is right at the moment. I should probably remove this. I don't think it's being used by anything. The ones you use the most will be copy and fill, and you can enable and disable transparency as well. But yeah, just if you want more information on this, talk to me off stream, and I can kind of guide you through it a little bit more, exactly how it works. But the macros should cover you mostly. So the length here is the number of bytes we want to fill on the screen. So that's 80 columns, 25 rows. And we've only got 1 byte. I'm going to put the times 1 in because it's kind of relevant in that we're only using 1 byte per character. When we change to 2 bytes per character, which we'll be doing soon, that will move to 2, like so. Hopefully this should can allow PRG to be injected. Okay, what's that? No such file directory. Why is that failing to compile? Is there an error here somewhere? Oh yeah, it's an error. Okay, clear screen. Yeah, and there you go. See, it's cleared the screen now with DMA. The great thing about DMA is it will do the same job as you doing it manually like in less than a raster line. It's so quick. It's unbelievably quick. You'd say it's better to use enhanced mode DMA. The DMA mode can be dependent on the C65 ROM you use. If using no ROM, it's F018A. While with the enhanced mode DMA, you can specify also with additional features. The transparency is missing in. Okay. Oh yeah. So one of the things that's in the hardware, so in the hardware Mega 65s and the dev kits, There is a special job type called the spiral job type, which which I think Paul added because he wanted to beat the 51 bytes. So it is possible to do a challenge spiral on the Mega 65 in 40 bytes apparently. So kind of interesting. But yeah, this will clear the screen incredibly quick now. We can just guarantee, we just verify that that's clearing screen by filling it with A instead. So again, this is our fill by. Uh, and you can see there it's filling the screen. So you can see how quick that is. So I'm going to leave it on A for a minute, and the reason I'm going to leave it on A is because we're going to do the same thing. We're going to create another one, but this time we're going to use color. Let's change this to clear screen job. Let's make these all match. And we'll call this one clear color job. Um, See, you may want to make these optional here as well, like a value you can pass in. But unfortunately, I don't really have that. Actually, what you could do is you could set this value here. So if I did, let me work out where it is. If I can work out how many bytes in it is, that's so we can work it out. So it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's going to be 10 bytes in. So if I did, um, let's try it. Let's try that. So if we set clear screen to 01, set that back to 20. So by default, it will be blank, but then we can do store the accumulator at clear screen job plus 10. This is the fill byte. So even though our macro is generating the code and putting 20 here, at runtime, we're storing a different value in that location. We should be able to do the same down here as well. So keep that there. Okay, so let's just try that out. Hopefully this will still work. No, I've created an error somewhere. It's screen job. It's screen job. Yep, plus 10. Unknown symbol. Clear screen jobs. It's freaking there. I can see it. Is it because that's... Wait, no, that shouldn't work. That should work. I mean, why is that not working? So this is the unfortunate thing with these. Uh, got a problem there. Hang on, let me work this out. In fact, let me pour another crack, and I need some. I need some more. More stuff. Oh, what's that background? Look at that one. Oh, okay. This is Stockholm. Okay, cool city. I like Stockholm. Okay, I'm not sure why that's not picking up. Clear screen job. Clear screen job. That's it should be fine. For some reason, it's not finding it. Maybe that is not available yet for some reason. Um, Maybe it needs this. I mean, it shouldn't do. It should be within scope, but no. Okay, so it's just failing for some reason. Unknown symbol clear screen job. Oh, thank you. Who said that one? Sharats. Points for Sharats there. I'm looking at the wrong line. Thank you very much. Newberry there. Give some points away. Let's give you +5 there. There we go. Thank you very much. I'm looking at this thinking, why is it not working? Why is it not working? I'm just looking in the completely the wrong place. So thank you for that. Sometimes you just need a second set of eyes to look at things, and that's why we have the AMK points. So Actually, that's not doing its job, is it? Because it's still clearing this area. Maybe I'm writing it in the wrong place. Let's have a look at the oh, parasol stars. Is it 10? It should be 10. Let's count it again. So the header is 1, 2, 3, 4, 5, and then the full job is 6, 7, 8, 9, 10. Oh, and I've counted from 1, so it should be +9, not 10. I count like a human, even though I should count like a computer. I should start at 0. Um, okay, that isn't right either, is it? I'll get it right in a minute. No, it should be 10. I swear it should be 10. Let's look at it again. What am I doing wrong? So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. It should be 9. Okay, well, we'll come back to that. We don't necessarily need it right now. We'll come back to that. It should be 9, though. I don't know why that's not working. So if we want to do the same with color, we basically pick a color that we want to clear it to. So let's clear everything to white. So you can see at the moment, it's not clearing to white. Everything it's got the original colors from this screen. So you see this screen, it's got the original colors in here. So if we want to clear to white, we're going to pass a fill job with 1 as our color that we want to pass in. And we're going to set to color RAM. Now, color RAM is interesting because color RAM exists in a couple of places. So there's the normal color RAM that we used to at D800. Let's set a color of black actually, so we can see this happen. And watch what happens if we try and set this. And I wonder if anybody can tell me why this happens. Oh, I actually need to call it as well. Why is that not working? God damn it! I'm not having a good day, am I? Or maybe I don't have. No, color RAM should be banked in. All right. Well, there should be color RAM at this location, but maybe that's not. I wondered when somebody would discover that one. Ah, okay. Oh, yes, of course. Thank you, LGB. Yes, so there is another flag that you would need to pass to do this. So if you ever want to DMA into the IO area, the destination bank, which is by 8 bit 7, needs to be turned on. You shouldn't need to do this really. So anyway, it doesn't matter because there is another color RAM. There's another one. I believe it's at this location, I think. Let me just check that in the memory map. God, I'm having a nightmare with things today. I really am. Uh-huh. Yeah, the IO is mapped in, isn't it? So it's a bit different. I keep forgetting. I think that's the right address. We'll try it anyway. So if I try and map that color in now, that wasn't that. Maybe it was 3Fs. Hang on. Yeah, that's probably right. Oh, XV0. I knew it was one or the other. Yeah. Ah, yes, of course, because it's 32 kilobytes, so it makes sense. Still not mapping though for some reason. Color RAM, run DMA job, clear color RAM job. Clear color RAM, color RAM. Okay, should be working. Oh man, I'm in a nightmare with these things today. I've not even got onto basic things. I wanted to make something interesting, but I seem to be fighting against everything else instead. So let's get another side on the go. Get my little smoke thing going. I'm sure this is not being very much help to anybody here. So. Basically, if you have but it's because I'm trying to show you. I mean, maybe I shouldn't be showing you how to do these things if they're not working. For me 100%. The problem I've got is I've got so used to using the real machine now that I'm not doing a lot of these, and I have a lot of these already set up, but I don't know why this color one is not working. That's really odd. The normal color RAM is too small. You can set it to 2 KB mode, but you're better off just using this upper area anyway. You can relocate it as well though as well. So fill job 0 to color RAM this many bytes. Not changed. Okay. I don't know what's going on here. Okay, just out of interest, I'm going to also run this at the same time on the real machine. I just want to make sure things are behaving the same on both machines. So we'll run it on here. It should run, and then when I close it, it should run on the real machine. See if we get the same results. Throw these in. It's going to be the quickest way for me to determine if there are. So yeah, I've got something wrong here. Try to do C64, C65 color RAM. The last 2 KB of the first 120K. Okay, so that would be. I don't understand why that's not working though. That should work. Maybe the DMA doesn't work there either, but I'm sure I've used that before. So the last would be right. Yeah, I'm doing something wrong here, Anna. I'm doing something wrong. What am I doing wrong? I think they well, the moment you call a DMA job, it halts execution on the main CPU until the DMA job is finished. When the DMA job is finished, it's oh yeah, sorry, F800. What am I thinking? I can't even take 2 KB off. Jesus, my head is. Thank you, LGB. Yeah, CPU is halted during DMA. But DMA is so quick; it really is beneficial to kind of transfer stuff over to for the DMA to do. Okay, that's interesting. So this works, but but this one. Okay, let me just copy that line. That one worked, but this one didn't for whatever reason. Which could be down to my DMA job not transfer. No, the reason this is not working now is because this is now in a different bank up here. You see. So the way the banks work is these are your main kind of memory addresses. This is your what's called the megabyte bank, I guess. So that would mean in order to get that to work, what I need to do is I need to change my destination here to use 0f because now now my destination is pointing to a much higher bank up there. In fact, it's not that one, it's this one. Let's make these hex so they're all the same. So that's why that's not working, because you need to set this last digit. It's the sixth digit here, basically. So it's still not fucking working. Oh, because I've missed one off. There we go. Yes, it's that. Okay, so this byte here. Okay. Or maybe it's FF. It might be FF. I can't remember. It's FF. I think it might be FF. Jesus Christ. My memory is so screwed up here. Oh, maybe it is F then. Oh shit, what have I done there? Okay. Oh. Really? Is that can't be one, surely? I think the problem is the DMA header here. Let me just check my DMA header. Source bank, destination bank. Oh, okay, and I can see why those digit weren't working, because these are only included if this is more than 0. So, so in this case, this is 7. Um, I want this to work. I definitely want this to work. So, hang on. Do you know what? I'm sure I've got this in my Turrican code. Let me just check this. It's in- F, F8. What we've got here is F, F8, 000. So this is correct. Let's try setting that to that. Do that actually. Don't you need to set registers in the DMA? Yeah. So the way the DMA works is it has you can probably just about see it in the bags here. So this is our source, and this is our destination. There are 3 bytes for the source and 3 bytes for the destination. So that's the bottom 3 bytes. But you need that last byte, and that's what the header is doing up here. The header is setting that destination bank here. But for some reason, it doesn't seem to be freaking working, which is really, really frustrating me. I don't know why. The address is correct. Let me try the address that LGB says. Although I don't think it should matter. It should work from FFD0800 D08. It should work from that original address. I just feel like getting drunk. I feel like getting completely drunk and just just not caring about any of this. It won't be a completely fun stream, but it will feel fun to me. Oops, I pressed something, so I need to restart. I broke the keyboard pipe. Oh, it's filled a single color. It's filled one single color up here, and that's what? Wait. If that's filled one single color, yeah. If why do you only fill one though? The length is set to something quite big, so. But it is affecting it now. But the problem is this is the address, right? That is definitely the address. Yeah, that's what this header is here. Um, that's what this is. Maybe that is FF, and I'm getting things confused here. And actually, that this value in here is wrong. Uh, oh, wait a minute. I think it's that. I think my macro is wrong. I don't think I've ever used these macros for doing color. Let me fix these. That's good. That means we've found a bug in here. Uh, as I say, I will upload these later. Zero F. I think that's the bug. Or not. 1, 2, 3. God. Oh wait, FFD. That seems more FFF8. Wait, that's the difference. And I always forget the exact. Yeah, I see Vic 2 man, Vic 1. Isn't it and not and? Not for anding, no. This is a logical and. I don't think it's working anyway. God's sake, I'm so annoyed. I'm so annoyed that I'm wasting so much time on these stupid things. Yeah, I hate days like this. I really do. Add it plus 800. Okay, so FD X. So X is 3 for Vic Foremost. So 3. So FD 300. So it'd be F. Yeah, that's what I want. The color ramp only error, not via the yeah FF8, which is exactly what I'm trying to use. But the DMA mode is failing me for some weird reason, and I do not know why. Well, I'll tell you what. Let me just demonstrate that this is the correct area, so I can demonstrate that it's my DMA setup that's wrong. So the way we'll do that is we'll just create some values and store them in zero page. So let's just put 0 into 02, 03. Let's load. What was it? F8. Oops. Store that at 04. 0F. Store that at 05. And then if we load Z with 0, load accumulator with 1, and store that at 02, comma Z, turn that job off, we should see that color change in that top corner, which will show, yeah, so its color's changing fine. So the address is correct. FF800 is correct. It's this job that's wrong. And it seems to be when I think it's to do with headers that aren't using so that aren't using the bank 0. So it's to do with the bank. So this is LSB, MSB, the 24-bit MSB, and then that is F. So that is definitely the bank F. Then this color RAM would be color RAM. I mean, let's just AND it with. That's the right values there. Then let's go and have a look at the fill job and see how that works. Okay, so the fill job is taking a source byte, which is just the byte that we pass in. This will be padded with a 0 on the MSB. The back byte, which is just 0 as well. So in fact, let's just put 0 there. We don't need to do anything there. Let's get rid of that one there because it's a fill job. We're never going to be going backwards. So then the destination, which is our color RAM, ANDed with FFF, which just make sure I did that in here. Yeah. It's going to give us the low 4 bytes of it. And then this would be the upper 4 bytes. The lower 2 bytes. And this gives us the upper byte next. this looks absolutely fine. I don't see why this would be broken. Um, there's a note in the user manual about the DMA not being able to access the color RAM above the first megabyte of RAM. Yeah, that's what this header is about. That's what this is about. It allows you to change certain settings about the DMA. So that's in. You'll find that information in the Mega65 manual, by the way. Let's try again. I don't see why this is not working, but it isn't working for some weird reason. Just check on the real machine. So it should be loading on the. But oh, what's that one? Did someone discover that one? Oh yeah. Yeah, it's the same on that. So this DMA job is just not working for some reason. Let me try. Let me try running it instead of the just on its own without this clear screen. Maybe there's something to do with the DMA chaining that's gone wrong. No, it's exactly the same. See, so okay, so it's not reliant on the previous DMA. We know that this is proof that the address is correct. The color doesn't matter here. It's literally just this DMA header for some reason. Yeah. Hey. No, I've deliberately hidden the list of discovered backgrounds. You have to remember them. Um, Thank you for the follow, Hamidi. Appreciated. Cheers. Cheers you with the cider. Oh my god! I tell you what, I wish I was doing Perseus now. I don't have anywhere near this problems with Perseus. This isn't anything to do with the emulator. This is just me getting the DMA wrong. I'll tell you what, let's try writing the DMA out manually. Okay, so the DMA is just a list of bytes, right? So the first thing is in fact, let me just open this up in a split panel, and it's easy for me to remember what the things are. Okay, so the first one is the job type, the request format, which we've got here. And then we need to set the source bank. So let's actually set them directly. Maybe it needs to set both of them because we're only setting one here. We're only setting our destination bank. We're not setting our source bank. But by default, the source bank should be 0 anyway. So we're saying that the destination bank is F. And then that's all for our job options. So we end that with a null byte to say that we've filled our job options in. Then we decide which job type we want. We want a fill job, and we don't want a chain, so it's the last request. So it's byte 3. So the first 2 bits in this say which type of job it is. You can see that in the C65 manual. There's copy, mix, swap, and fill. Then the bit 3 says whether or not there's another DMA job straight after it. Just do that stuff without DMA. I will do if this doesn't work. Yeah, I will fill it. It's just a shame that it doesn't work. It would be a shame not to have this working with the DMA. So, well, we'll try it out first. So, okay, length is this value here, which is our screen size, basically. Have you set the previous DMA to chain? No, it's on false, so it doesn't chain. And it doesn't work. Just before I did this, I turned that previous one off. So let's put that in brackets as well, just so it's obvious it's a evaluate function, evaluate value. 1881. Have I got that wrong? Oh, is that what it is? Oh my god, LGB, you're a genius if that's what it is. Have I made a boo boo and picked the wrong header? stuff, and it's just never bothered me because I've never had to test anything outside that header area, outside the normal banks. Is that what it is? 1881. You sure? So I need to check this because I'm annoyed if that's the case. I've coded the macro wrong, and God, where's the DMA in here? Oh my God, where's the DMA? I've lost it. DMA controller. Really? Don't have any information about it on here. Oh my God, you're right. Yeah, LGB is good. You know what? Even though you don't visit the stream, you're still going to get points for that because that's a great catch, and that's been driving me mad for a while. So that's a 25 pointer. Thank you. So we have these. They're called AMK points, named after Andy because he was the one that kind of coined the phrase originally, and has been kind of after them for a while. Um, so I think this is going to work now if I change this. Let's just get rid of that. Let's comment it out. And let's go and fix the macro. So the macro problem is in here, I'm using the wrong things. It should be 1881, not 81 and 82. And if this works, I'm going to take a quick break as well. It hasn't worked, but that's probably now because I've got some things wrong in here through messing around with them too much. So let's keep color RAM as is there. Change that to FF instead. And let's change this like that, I think. Boom. There you go. Cool. Definitely worth the 25. Thank you, LGB. It's so annoying when you do that as well. I mean, this is what happens when you write these libraries. You skip through them really quickly. But yeah, there you go. Cool. Thank you for spotting that. And this is why 25 point it's a 25 point because I've already spent a long time looking at that and I just wasn't seeing it. So thank you very much. Right, cool. I'm going to take a quick break, guys. I shall be back in 2 or 3 minutes. I'll leave you with the races. When I come back, we'll get on to something a bit more interesting. We'll move on to the next section. But you can see how DMA works, and I will fix up the macros. Well, the macros are fixed up now, and I will save them to the folder so you can to the repo so you can mess around with them. Okay, cool. God, that was annoying. Right, back in a few minutes, guys. Be right back. But anyway. I think I broke the quiz as well. I don't know if I fixed it. I did press a few buttons. I may have fixed it. I may not have done so. Frobo, is it still broke? If it's still broke, then I'll re. It's still broke now. Okay, I'm going to restart the overlay then. Let me stop this particular one. It seems to be working though. Is it? Is it still knackered? Okay, I'm gonna restart because it's going weird. Okay, I've completely forgot what I was up to and everything now. Uh, yeah, I was about to have a drink. Good idea. Really good idea. I feel like this is broken now. Done. Scunthorpe. There we go. That's gone. For some reason, the background timer is on 0 as well. What is going on, man? Oh God. Yeah, everything's at 0 all the time as an knackered. I don't know what I've done. I've broken something massively. Let me refresh it again. Try it like that. Ooh, see behind the scenes now. What have I done? What have I done? I've completely broken something. I've broken something. I have no idea how to fix it. The timers are at 0. It's the DMA. I'm just not having a good night at all. Oh God. Oh fucking hell! That Coke as well. Fuck's sake. Thank you for the follow. Oh, I've had a couple of follows. Thank you, Real Armvar and Aport as well. Thank you guys. Um, yeah, I don't know what's going on. So I'm sorry everything's broken. I don't know what's happening. Um, what I don't understand is why the timers are not working or anything. So what I am going to do very quickly. I'm just going to restart my background server. Hang on. I'm going to do this, and I'm going to refresh the page once more. Last chance. If this doesn't work, then I don't know what. See, it should say ready up there, and the timers should refresh. So I don't know what's going on. Okay, yeah, exactly. All right, let's get the quizzes back up. Do you know what? You can. I don't normally give another 10k, but I'm going to give another 10k just because you've all been very patient. You've all hung on and waited. Somehow I've still got 47 viewers, even though for the past half an hour I've done nothing but nothing. Well, I've done nothing. So thank you for persevering with me. Let's get the race back on and let's crack on. All right. So I've covered DMA. If you want more details about how the DMAs work, then get in contact with me on Discord. And I'll try and go over it in a little bit more detail. But essentially, you set some values in here. In fact, if I set this value directly here, by just grabbing that value, so that is 4, 8, 12, 16, 20. Okay, so what was that value there? Was it FF? Yeah, okay, so this is so basically you're grabbing the last 4 bits of the 24-bit address. That's what goes in there, and that would be the same here as well. Um, except that value just happens to be 0. This one here. Um, so there you go. That's the thing. So the other thing I'm going to do now is just add these fill bytes in here. I'm actually going to change the macro so that the length is known. So I'm going to get rid of the in the fill job anyway, so you can fill it with whatever. Is it this one? Oh no, it's the header, isn't it? Damn it! All right. So I'm just going to get rid of these. I may put them back at a later date, but for now we'll get rid of them. This is going to ensure that this is always the same value here, and then that way we can set the values that we want to clear. So now if I set these values, I should be able to clear the screen with, let's clear it with B, and let's set the color to red. And they should work on both of those now. Oh my God, what have I done wrong now? I've just got no patience for bugs now. Clear screen job. Oh, okay, that's just not clear screen job. It's clear color RAM job. Go. Reach back now. Messages. There we go. Cool. So now it's dealing with uh, different values as well. Okay, so it took a little bit of time, but you can see now how you can clear the screen and clear the color RAM with DMA. And the great thing about that is we don't need to set up a 32-bit zero page pointer for it or anything. God, I got really itchy back for some reason. Actually, I've got a ruler here. Scratch my back with a ruler. Sorry. Oh, there we go. Well, that's about. Okay. Oh, Death Star did work. There you go. Can you run DMA command list anywhere or just the bottom 64K? It has to be the bottom 64K because you're still pointing to you run this DMA job here, you see, and in the DMA job here. Oh, actually, you maybe you can do more than that. I've never tried actually. I've never tried. Unfortunately I can't because of the way it's loading in at the moment, but maybe you can because it looks like the top the top bytes of the thing. Yes, you can. Okay, cool. So you can put that DMA job anywhere you want. Um, Actually, I think I already do that. I think I do that in my Turrican character set. I think the RAM, the character RAM actually has DMA jobs embedded into it. So there you go. All right, let's move on to something else. So let's have a look what else was on the list. Hopefully, we'll have a better look with the next stuff on the list. Because so far tonight, my luck has sucked. Memory banking. Okay, we've kind of gone over memory banking. DMAs, we've gone. Bobs or soft sprites. Okay. Soft sprites is a tricky one to cover in a single stream because it's not really like there is a system set up for that. It's it's really just using the raster rewrite buffer to kind of simulate sprites. I would recommend looking back through the Perseus streams for that. I know FaZe, you said that they have been covered in Perseus. I think that would be a topic for a whole stream to go through that system. I don't think it's really fits well into this one at the moment. I said I don't think I've got the patience to do that right now. I want to do kind of simple things. Um, but essentially, what you do is you define a screen that's twice as wide or more. The first area of the screen is your screen, the other stuff that you draw like normal, and then the additional bytes on each row are used to kind of retrace the raster. Sort of retrace the raster is kind of buffered ahead of time, but you can think of it as it retracing the raster. I did a video on the raster rewrite buffer on YouTube. You can check that out to see how that works. But basically, you create a sprite list. The sprite list has characters that make it up. And then you just retrace to draw each one, setting the Y position and stuff like that. Different options for the char screen modes, colors, custom char set. Yes, okay. So let's we talked a little bit about this last time, but let's go into a bit more detail on this now. So the first thing to note is that you have three options currently on X emulator. You don't have the fourth, which is the more kind of recent. Oh, you guessed that one. Well done. Hmm. Tron got one, and then Steps redeemed one straight away. So, but well done for discovering one. You didn't get to see it though, I don't think. Um, yeah, so you have three options for character modes. I think there's three. Yeah, at the moment on XMA. So you've got the standard C64 high res mode, which is what you see here. Uh, where you have a single color in each character space and a background color which is shared across the whole screen. So this is what you're used to in the standard high res mode. except this is in 80 column mode here. Thank you for the follow, Chew King. Welcome to the stream if you've just joined us. Then you have multicolor mode, which is basically the same as it is on the C64. You will set that with the same values. It's worth remembering that the values for the VIC register, VIC2 values, are pretty much the same as they are on the C64. So setting the same values should produce the same effect. This isn't going to work because it's going to be low colors here. If I set the color to something in the upper region instead, so the same rules apply. And you can see there I've now selected a multicolor mode, and the same rules apply. You set a color above 8 or above, and you get multicolor. Set a color less than 8, and you get high res characters. So it's the same thing both ways. Hey Jamie. Yeah, it was a little bit crazy today. It's been all right though. It's been a good stream. It's been a bit manic. I've kind of had some crazy bugs and a few personal things I've had to sort out as well. But we're back on track now. So you can treat even the 80 column screen as multicolor or high res exactly as you would do on the C64. There's no difference with that. You're setting the same values in here. You can do the same things pretty much. There's a few things that won't work quite the same. Screen kind of shifting is one of them, I believe. It doesn't work properly in VIC4 mode because you don't need it in VIC4 mode. Your screen scroll is done completely differently. So, but they're the two character modes that you're used to. The third one is full color character mode. So, full color character mode is enabled by where is it? On the VIC4. Here we go. It's enabled by setting some bits in D054. So D054 has a couple of bits in it. The three that we're interested in are the lowest three. There are more in the top end. In fact, let's do this with a set bit like that. TSB. So in order to set full color mode, you need to do a few things. First of all, you need to turn on 16 timer. What are you on about? Oh yeah. Blue screen of death. That's a good one. Yeah, when the timer's up at the top, they do get ignored. So to set full color mode, you need to first of all you need to turn on 16-bit character indexes. I believe anyway. Let's try it without. I think you do need to turn them on. I always do turn them on. So that's bit 0. Bit 1 is the so let's do it with this 1, 2, 3, 4, 5. So it's these last 3 bits here. So this one here is the 16-bit character mode. Then this is full color characters for full color mode characters for characters. BGDMA enhanced mode list option. um, so let me list up here what these are. So D054 equals full color char modes. It has some other things in as well, but for now we're going to use it for these things. So bit 0 equals 16-bit char indexes or indices. This means that to use a character, you supply 2 bytes rather than 1. And that the first thing that will do is it will mean that the whole screen will now take 2 bytes per character on the screen. But we're going to try and just do it without enabling that first, and we're going to just try doing these. So this will be full color mode for chars less than or equal to FF, and then this will be full color mode for chars more than FF. So on the C64, you only ever have chars from 0 to FF. That's you have 256 characters. They're numbered from 0 to 255. and that's these ones here. So that's what setting this bit does. This turns full color character mode on for those indices. But in 16-bit char mode, you're allowed to have more than 256 characters. And so you would turn this on to turn full character mode on for those. So I think you have to have 16-bit mode enabled. But let's try it with that. Let's just do like so. So we're just turning full color character mode on for characters less than FF and see what happens. I don't think this will work though. I think this will. Oh no, it does seem to have done something. Okay. It's put BT Oval Office again. Uh, it's broken. Why is it broken? No, I think Anton did Oval Office. Oh, Doncaster's broken, not the stream. Okay, so this does actually seem to be changing the character into full color character mode. So that's interesting. I didn't know you could do that. Um, so I just wonder where those characters are now. So let me just check on the Mega65. So I'm just looking down here because it's on the Mega little 65 screens in here as well. So it looks a little bit different, but it is doing full color character mode. So that's interesting. Um, so what I understand the full color character mode is that the characters are stored anywhere in the Vikram. You don't have to set where those locations are. So um, like you do with the C64, where you set which Vic bank you're using, and then you point to which section of which 2 kilobyte section you're using within there. Um, on the Mega 65, you don't have to do that. Instead, what you do is you use whatever memory address you want to use. So we'll do it here. We'll just fill this with zeros, and then your character number is. Let's fill it with one actually. Your character number is this address, whatever address you want. So in this case, 3000 divided by 64. That becomes your character number. Um, so in this case, this means that this is actually, is that going to be in the low? And that's not going to be in the lower, is it? It's going to be. Oh no, yeah, it would be. It would be 0100. Okay, so this would be C0, I believe. I need to type that in. I think it's C0, C0. I think anyway. Let me put that in the calculator. So it's 3000, but preferably in hex, divided by 40, which is 60 in hex. C0. Okay. And the reason for that is because every character is 64 bytes. So each new character index is 64 bytes past the last one. So if we try and fill the screen with C0 instead, which we can do here. No, sorry, that's the color. I'll talk about color RAM as well with regards to this in a minute. You can see it has actually filled it in with the color. So that has worked actually. It has worked, but it means we're still using single bytes. So you can only use character ROM up to uh, this location in this particular mode because we're still using 8-bit character indexes. So this will only work up to this point. Beyond that position, you need to start using 16-bit character mode because this is how full color character mode works. It doesn't use the char gen address. It uses the address divided by 64 as the char index. So if we wanted to put some character up here at 8000, for instance, we can't reference that because that is actually at that's the character index, and this is a 16-bit value. So in order to use that, what we need to do is we need to turn this on here. So that's this byte here, and also we need to turn this on because the character is 200, which is more than FF, so we need to turn that on. So now we turn full character mode on for them all. Now the reason why you might want this is because you might want to keep like just a normal bitmap for a normal high res font or something in the lower areas. You might just turn it off so you're not using full color character modes and therefore saving a bit of memory. In which case, I think if you do that, it will use the char gen for those ones. I don't know for sure, but I think it will use the chargen address for those. Again, chargen address is in the manual, and it is, if I can find it, D068. So you set the address in D068. So okay. So now we've turned full color character mode on for them all. You'll notice now, when we try and fill the screen, weird things are going to happen. Firstly, the screen is not going to fill completely, and that's because now we're using 2 bytes per address instead of 1 byte per address. So this is very different now. Okay, so the screen is twice the size, which means we now need to change our clear jobs here to something different. Um, Additionally, this is now going to fill both sides, both the LSB and the MSB um, of a 16-bit value. So now the DMA needs to be a bit smarter about how this works. I think actually by default the 0 will be blank anyway. So if I just set that to 0, I'm hoping that will be blank. Yeah, 0, 0, 0, 0, 0 is a blank character, which is fine. That just happens to be that because that area of memory is blank, is 0 page. If you start putting stuff in 0 page, that won't be the case. So for instance, if I think that's right. Oh, no, it's not. It's not happening either. Okay, I'm not sure why. Say, all right. Anyway, the point is now we need twice, which we've got here. We're filling twice the amount of memory. Then to draw something on the screen, we need to use two values. So if we wanted to fill the screen with this value, we need to DMA 2 values into here, which means this is a little bit tricky to do. So I actually don't have steps set up in here either, unfortunately. So let's do another clear screen and call it clear screen 16-bit. So this time we're going to actually create our own routine to clear the screen, and we're going to fill it with the 16-bit values that we want. We could do it with DMA jobs, but I can't be bothered setting up the macro for that. And this is a kind of this stream's a bust anyway, to be honest. I apologize to everybody for tonight. Not my best stream. In fact, it's probably one of my worst streams. But you're all enjoying yourself, it seems, anyway. So best stream ever. Yeah, I'm sure, but I don't believe you. So I'm going to create a virtual piece of memory here. I'm going to call it 0 page. It's going to be virtual, and I'm just going to put screen here, and it's going to be a D word. We're just going to set this up to be screen RAM. We'll do it in here though. So this is going to be 0 because we can't address anything outside of this bank anyway. This is going to be, that's the right thing, screen RAM 16. Always like to do that. It's probably not necessary with screen RAM, but I'm going to do that anyway. Maybe that. So there's screen RAM is now set up in that 0 page address. Then all we need to do is we need to draw things to this screen. So we're having a nice stream anyway. Ah, good. Okay, come on, say where's he doesn't come to this stream anymore. He's I don't know why he just doesn't come anymore. He unmodded himself a couple of weeks back, and then just stopped coming to the stream. And yeah, Yeah, shame, but you know, if that's what he wants, then fine. I'm not gonna argue with him. Don't have a problem with him. So I put an RTS at the end. All right, so load said 0. So what we're going to do is we're going to do one row at a time. We're going to increment the Z value. We're going to keep Y as a row counter. So we'll start that at 19. So each row will be decreased to Y. If it's not equal, then we go back to here, which is going to be our main loop. Actually, this is going to be our main loop. So let's call this loop. And this is our inner loop. And our inner loop is just going to take two values. It's going to do two things at a time here. So first of all, it's going to take the lower byte of this. So it's our memory. This is hang on. Char index for this is 0200. So this is the char index we're trying to put in the screen. So that means for every location on the screen, we need to put 00, then 02. So let's do that. So we're going to take. Where the hell have I put that now? God's sake, I can't concentrate at all. Yeah, there we go. 00. Let's actually do it like this, and then this way we can pass these values in. So when we go to clear the screen 16-bit, we can pass. There we go. So now we can clear the screen with 16-bit. We don't need this really, and I'll explain why when I've filled the screen in. You'll see why. Um, uh, I enter in this month's giveaway. Let's have a look. Yes, okay, we've got a couple of maybes as well. That's good. Please don't see tonight's stream as an indication of how it is to program the Mega. It's much easier than I'm making it look. I'm really making it look very difficult tonight. I don't know what's wrong with me at all. I'm just not having a great time, to be honest. I'm having a great time being with you guys, but I think it is a lack of booze, isn't it? Yeah. I'll tell you what. Let me reach behind the magic curtain up here. Pull my headphones out as well. Looking forward to seeing that. There isn't really a game here at all at the moment. This is unless you're not on about that. Maybe you're on about something else. Anyway, I've got. I need to go and get another Coke in a minute, but I'll do that when I've drank these. Okay, so we can pass these values into this function now. So now we're going to in this loop we're going to put them into the address in memory. So all we're going to do is store them at ZP screen. Comma Z, it's 32-bit addressing mode, which in Kick Assembler means we need to do the double brackets like this. Like that, we need to increase the Z after each one. And now we need to, if we've reached the maximum number of characters for the screen for each row, then we need to we need to advance the row and go on to this. So in order to do that, we need to compare Z. Now there are 80 characters on a row, so 50 in hex, but we're 2 bytes per character. So this is actually A0 is what we're looking at here. So if we've not reached that value, we just go back and we keep doing it until we have reached that value. And when we do reach that value, we can now increment the screen address. So this is where one of the nice things about the one of the nice things about the Mega65, you've got a nice instruction here which helps with 32-bit increments, especially when you're doing screen updates. So in order to increment, we need to add this amount to our screen address. So what we need to do is we need to clear the carry bit first. We need to take our ZP screen plus 0 value, and we need to add A0. So this is the size of a row in bytes. Now you can change this. You can change this size to whatever you want it to be, but the default will be A0 for the row. I did a video on the raster rewrite buffer, which covered kind of changing that value to make the raster rewrite buffer work. You store that there. Now, what you can do is if the carry flag is clear, you can just skip over this. Just go to here. If it's not clear, however, what you can do is you can increment the word at ZP screen plus 1. And what that will do is it will increment ZP screen plus 1, but if that overflows, it will also increment ZP screen plus 2 as well. So that's a nice nice addition, for especially for doing these sort of things. Saves you having to do another addition and another carry check and stuff. So you just do it like this. Really handy. Likewise, you can, if you're just incrementing a 32-bit number by 1, you can just increment the bottom 2 bytes by using increment word and then do a check if it's 0. If it hits 0, then you can increment the top word as well. So for instance, to increment a 32-bit value, I'll put this in here. I'm just going to put a little snippet in the middle. I'll leave this in place. So increment a 32-bit value by 1. So what you would do is you would do increment word value plus 0. So that it's going to be at value 0 to 3. That's our 32-bit value. So you can increase the word that's at value. So it's going to increase value 0. If that overflows, it's going to increase value 1. If the whole thing reaches 0, then the 0 flag will be set. So what you can do is you can branch if not equal to here, then increase value plus 2. And there you go. That is how to increment a 32-bit value. So really, really quick. You could do 64-bit like this as well. So if you wanted to do 64-bit, you would just add more of these on. So you could just do, like that, and it would be like that. And there you go. You're incrementing a 64-bit value and so on. It's really, really simple. Unfortunately, there isn't an increase. It would have been nice to have in DW. I think there is an in Q actually. Which uses a quad register as well. But I don't really use the key register very much, to be honest. So, but I'll leave that little snippet of code in there because it's it's kind of nice to see that and see how efficient kind of 45 GSO2 can be when you do these things. So even though that's no use to anybody, I'll leave it in there. No use in this code anyway to anyone. So there you go. That should be incrementing the screen row, and we're going to jump back to here if we're still on a row. So now this should clear the entire screen with that character. So hopefully we should see, okay, we see an error. So what's the error? Clear screen 16-bit. I'm in the wrong file now. Clear screen 16-bit. Have I put a capital B in? Yes, I have. All right. I feel like that's not actually putting the right character in there because it should be white, I would have thought at this point. Zippy screen, come Z. Screen RAM, upper screen RAM, screen RAM. Yep. So that's all correct. That should be fine. This should be 0. This should be 2. StoreX MSB. Yeah. 802. Okay, that should all be correct here. Oh, interestingly, it works on my Mega. Okay, look, it kind of works on here. There's something not quite right. In fact, it looks like it's got lines through it. Oh, it has got lines through it. Let me turn on my big TV. It's easier to see all that. Okay, I don't know why it's only done half of the screen there. That's weird. 002. So this would be size of a row in bytes. I should be going onto the. No, that shouldn't be the initial memory values as well. So if I don't do that routine, shouldn't be anyway. God, I was so. I should have just done Perseus tonight. I really should have just done Perseus. I know where I am with that. This is a nightmare for me tonight. Sorry, I'm moaning a lot, and I'll stop moaning now. I do think there's something wrong with some of the um the images because there's a couple that should have worked that didn't. Oh no, we looked at Death Star and it worked, didn't it? Okay. No, okay, so far it's so good. Yeah, so that's the initial values in that memory location. Um, and if I do that, it does actually draw something across the screen, but it only draws it halfway across the screen and then stops for some reason. Um, the row size of a row in bytes. Do I need to change that? I shouldn't need to change that. And in fact, you can see there it's going all the way across the screen. It's just for some reason I don't know. I'll tell you what. Let me try something. Let me open M65. Wait, 3, 4. Wait, what? One. Okay, so this is our screen, but it looks because it's all wacky because of what you've seen on there. So let me run it again with that screen stuff enabled. See what we get, and then I'll run. Need to close that, or else the Mega 65 won't run it. Okay, so it looks clear on there. The real Mega 65. Uh, okay. God, I'm pressing everything wrong right now. Fucking hell. Okay, so this looks correct. You can see the values in memory, all contiguous. They look fine, but for some reason, we get the wrong thing on the screen. This could be down to the color, actually. If I don't do the color RAM, maybe it will work. It's weird how we get two completely different values. Oh, I just want to cry. I just want to cry. So I've got M65 open, so it's not going to work. Damn it. Thank you, Andy. I need it. I think this stream is a bust. I'm sorry. Nobody's learned a thing from this. The only thing I've learned is that I should just. I don't know. I don't know what I've learned. Thanks, Doxter. PT hugs. Yeah. Okay. It's the color RAM initialization. So this leads me on to the next bit then. So the screen is being filled with the right value. But the problem is now we need to clear the color RAM with the same thing. Now the reason we need to clear the color RAM is because even though we're using full color mode, the 16-bit character mode opens up what's called super extended attribute mode, and this is in the manual. You will find it somewhere in the manual, and I talked about this last time as well. There's a little table in there, and it's in the Vic4 video controller section, couple of pages in, and there's a table kind of looks a little bit like this, that explains what each of the color RAM and screen RAM bytes do. And the color RAM does some interesting stuff. So color RAM in 16-bit character mode is rarely used to set the color. What you can do is you can use it to set which color is transparent. Um, but the main thing you will use it for is changing attributes in the color RAM. So attributes are much like we have on the Game Boy. You have things like the ability to flip a character horizontally, vertically. You can turn blink on. You can turn underline. So you've got hardware blink, hardware underline, hardware bold mode as well, hardware reverse, and you can trim characters as well. So you can make the characters kind of kern better than they do. So like typically the 8-bit machines have mono-spaced fonts, so every character takes the same amount of space up, 8 pixels wide. But you can actually set trim pixels on things, so you can make things kind of kern together as well, which is kind of nice. So I'm really learning, because within the time it takes fits my brain has the time to figure out what you're doing. Okay. Uh, there is a Mega 65 memory overview. I think Snoopy did one. That is able to be done without using rastery overlay. Yes, it is. But it's only gonna move a character by about 7 pixels in either direction, a single character. It literally just trims some space off the character that you want to draw, so it just changes the way it does. So Paul uses it in he's made like a PowerPoint presentation type thing called Megawatt, which is for the Mega 65, and that has kind of proper nice font spacing in it. So the fonts actually kern properly together. So, I mean, obviously, you would have to create a system to kind of print these characters on screen and then set these trim values. But that's what it's there for. It's there to make text look nicer when you've got large kind of text presentation screens. You can use it to make them look nicer. But the problem is if you have loads of random stuff in memory at that location, this is what you get on the screen. You get kind of junk like this. So if I was just to go into the memory and set them all to 0, um, I think that should probably fix it, actually. If I do fill FF8 1 2 3 4 to FF8, I mean 4000 is probably enough. 0. You can see there it's changed everything on the screen, and it's now everything's got the same attribute, which is nothing. So actually, we don't need clear color RAM 16-bit. What we need to do is clear the color RAM with zeros, and that should produce the same effect on the emulator as well, because we're now filling it with zeros, so it works. Yeah, I knew there was a memory map for it. Yeah. So that's really cool. So I'll quickly show you that now. So what this memory map is really good for is oh, hang on, has it changed? Where's the oh, there we go. What it's really good for is figuring out like where things are free down at the bottom. Now I haven't had time to show you tonight, but I used this when I was trying to figure out where to put my floppy loader, and I ended up putting it in this location here, which is just used by basic keyboard buffer. Obviously, we don't need that when we're in um, when we're in Mega 65 program modes, and I used this bit as well for the upper part. So I used 2 pages. I used both kernel, but well, one is basic. This one's a basic page, and this one's a kernel page. So they're kind of nice and free to use, and that's where I ended up putting my that's where I ended up putting all my my floppy loader stuff. Um, Um, yeah, I'm too obvious, aren't I? Yeah, I'm too obvious. Yeah, all right. I'll admit there is a ball cube, and you got the word exactly right as well. So yeah. Anyway, this is really handy to look through. I don't know if it's got the kernel stuff in it yet. Sorry, the basic ROM stuff. I guess it wouldn't do because BitShift is still working. Oh, it has got some of it in actually. Oh wait, is this the? Yeah, this is the basic ROM. Okay, but these are mapped in from somewhere else. I don't think they are. Yeah, you'd have to figure out where they're mapped in from. But yeah, I can't keep a secret. You're right. Anyway, it's a cool little site. It's changed a little bit though because or maybe I just went straight to this last time and I didn't go straight to the home page. But I don't remember seeing it like this anyway. But anyway, there you go. Um, cool page. Okay, so let's try changing the character a little bit. So the character is basically 64 bytes. We looked at this last on the last stream as well. 64 bytes, 8 bytes per row, and you can set the colors individually for each byte. So like that, we'll create 8 stripes of different colors. So when we run this now, we should see 8 stripes down. Well, it'll be all the way across the screen. Very hard to see actually at that resolution, but you can see the colors all there one at a time as we go across. So we've got 8 colors in that block there. If we were to kind of just make those a little bit wider, say, we should see white and cyan, red. I think I touched on the palettes last time. I'm not going to go over the palettes again. I think the palettes was explanation was pretty good last time, so I will leave that as a kind of task for you guys to kind of dig out if you want to. But the palette definitions are in here. The video was pretty decent. I don't think we need to go into talking about that very much now. One thing I will talk about very briefly is using Asaprite to build the character set. So let me load up an existing thing. Let me just be careful I load the right thing up here. Okay, let's take a look in here. Yeah, here we go. So this is the map I used for Turrican. Actually, I changed the background color on it. But what you can do, there is a plugin that you can get for this that Monsters Go Boom wrote. Um, and once you've installed it, I'll share a link to that in a minute. You get these tile miser things. It's called. It's this one here. Um, and what this one will do, I've got some variations of this, but this particular one, what it will do is it will just generate a character set of all these characters. Um, so you set Mega65 in here, set the offset. So the offset is where in memory you want it to begin. So we want it to begin at this location. So our offset is 0200, which is 512 in decimal. So we set at 512 here. We want it to remove the duplicates, and we want to save the chars. We don't care about the map at the moment. We don't care about the palette, but so we can save that out. Let's just save it into. We'll see how big it is. It's probably too big anyway, but let's try saving it. There are other tools as well. If you want to check the uh, if you want to check the it's been hidden by Mega65 screen. If you want to check the Mega65 file host, you will see plenty of. God, I'm in the wrong folder. You'll see plenty of other tools as well. I just use this one because it's what I've got used to from the beginning. And it's just what I'm using now. I find it quite easy to write these scripts as well. So I used the one that Monsters Go Boom wrote, but now I've kind of transitioned to using one that I've written in Node that runs as part of my build process. I will be releasing that eventually, but it's not ready for release yet, so I'm just going to leave it as a thing that you will see eventually, but just not yet. Um, so I'm just going to store it in here, chars.bin. I'm going to save it in there. I'm not going to bother saving the palette. I'm just going to save that. It will look awful, I guarantee it, but we'll do that. So it takes a little while to run because it has to go through the whole map and pull out all the matching characters. So it's found 1,562 tiles. So that's way more than we can fit in memory at this location, actually. So let's just trim it down a little bit. Let's just get this map and trim it down to a few pieces. So let's we've got a grid on here, so let's just grab this piece here. Let's just trim it down to that. So if I select that area, oh, I was drawing. I want to select, not draw. I just make sure that's the right size. It's not. It's one too big. And there we go. And then go edit, trim. Where's trim? Select. No, edit. Where's trim? Oh, there it is. Sprite trim. Sprite trim, please. Okay, never mind. Cut it out. Sprite. Where's this new sprite? There we go. So we've got a much smaller sprite. This should be really easy to do. So I'm going to take this one. I'm going to use that script again, which is in. Say I can't do anything tonight. Tarmizer, there we go. Again, set to Mega65. Our offset is 512 because that's the beginning of our character set. We're going to set chars.bin to be in here. Click OK, overwrite it, click OK. There we go, we've got 28 tiles. So now if we take a look, that's here, chars.bin. So if we go import, binary, chars.bin. So now that's imported at this location. And now when we fill the screen, we should see one of those characters on the screen. We won't see them all. I have no idea which one this is, but this is indeed one of the characters on that screen. So you can see how easy it is to import those things. I'm sure we can figure out which one it is if we look carefully. It looks like it's maybe the grass, actually, which would make sense, I guess. Actually, I'll show you how to import the palettes as well from here. Let me share this this repo with you. So you can go and grab this yourself. So oops. There you go. Oh, someone discovered Endor. There you go. Well done. What's that one? Who got that one? Oh, oh wow! You guys are going through it very quickly. God, you are hammering through these. So there you go. That's an Asaprite script. You basically you just drop them into a scripts folder in Asaprite, and then it appears in this script list here, and you can do all sorts of it. It's in Lua. It's really easy to kind of play around with and change. Lua isn't the nicest language in the world, but it does get the job done. So yeah, you can go in and mess with that. One of the other things it's really good at doing is exporting a palette. So we'll do that now as well. So if we go to the script and just set the palette as well. So we'd already set the chars that appears here. If we yes, we want to overwrite that, and we wanted to set the palette as well. So we'll set the palette in here. Call it pal.bin instead of chars.bin. And there we go. It exports the palette to match as well. Again, we need 5112, 512, sorry, Mega65, export. There we go. And now we've got a pal.bin in here. Now the pal.bin will be however many colors you've got. And you want this to be 250, 256 colors. So what you really need to do is just extend this to palette size 256. It tells you at the bottom. Oh, keep going over. One more, one more. There we go. It tells you at the bottom as you're extending it what the palette size is. So if I run that again, pal.bin, yes, overwrite that. Charles.bin, overwrite that. Set to Mega65, 5112, duplicate. There we go. And now when we look at it, we can see we've got a much larger file. And that's because we've got all three full palettes there. So let's import that palette then as well. So what we'll do is we'll create a little bit of palette code up here. So what we're going to do is we're going to do a palette import here. Pal.bin. There we go. And then we'll write a little bit of code that imports that palette here. So we'll call this import palette. And basically, this is just going to be the same as our set palette in here. We're just going to copy that code, pretty much the same as the set palette from the last demo code. But now instead of grabbing from, well, actually, we can just call it palette data here as well. We can keep the label, and there we go. That's it. That's going to copy the exact palette in. So now if we run this, we should hopefully see something which it has still not matched the. Is it not using the right palette? It's weird. Oh, because we're not actually importing it. Helps if we actually call the function. So we'll do that here straight after we set the vic up. Or cube. We've been waiting for that one, haven't we? So yeah, you can see it was indeed the grass. So you can see it's one of these grass pieces. I think it's this piece here by the looks of things. It's kind of hard to tell. But yeah, I think it is. I think it's one of those grass pieces. And that's because we're setting these values. If we were to change this value, we'd get a different piece because we're clearing the screen with that value. There you go, a different piece. And if I go a little bit further along, like 8 something, we'll probably get one of the rock pieces. And so, yeah, at this point, you're basically using the same system as you're used to using on the C64. You can see there it's using one of the rock pieces somewhere. I'm not sure which piece it is, but it is using one of them from somewhere in here. I think it's this around here. But it's just filling the screen with that value. So the next step to think about is 40 column mode versus 80 column mode. So I tend to use 40 column mode because 80 column mode is kind of overkill really for games. You don't really need it. So to set that is quite easy. There's a value called H640 somewhere. I cannot remember where it is. Oh, it's in the Vic. Oh, it's that D031. That's why. Yeah, so it's bit 7 of D031. So all we need to do, we'll do this in our setup Vic. In here, so 40 column mode, clear bit 7 of D031. So to clear a bit, we say bit 7 is 80, that's bit 7, and we want to reset that bit, so we want to turn it off. So we do that, and that will clear that value. And now when we run, we should have 40 column mode. And things will look a little bit bigger and wider, as you can see there. Now, the cool thing about this now is, of course, we don't need to clear quite as much memory because we're only using 40 characters across instead of 80, which also means we don't need to do our 16-bit clear. Doesn't need to be quite as aggressive in that it doesn't need to do this many. It only needs to do this many. And again, when we advance the row, we only need to add 50, not 80. say aggressive, that's kind of the wrong word, but there you go. You see it's clearing that screen now with these characters. And this is kind of the resolution most of the Amiga games would be running at, actually, roughly. Um, so really the 80 color mode, it's kind of unnecessary for what you want to do in the games. And in fact, uh, you're discovering all the Star Wars ones now. How many of the Star Wars ones have you discovered then? That's interesting. You worked out that who worked? Did you work out that was one of them was a planet and just go from there, or did you discover one? I can't remember what happened. Looks like you discovered. Yeah, it looks like you just discovered a planet. Yeah, I think Andy knows that. I think Andy's pulling people's legs with that. Just gonna have a quick look how many other Star Wars ones I've got in there. I think you've got the easy ones. Uh, okay. Yeah, I think you've got the easy ones. There are I can definitely see a couple you've not had. Uh yeah, I see a couple. I think some of the other ones are going to be a bit harder to get. Because I think you've got all the planet ones actually. Yeah, I think you've got the planet ones. The other ones are going to be a bit harder to get. But there are some more Star Wars ones in there. See you, Doc. Good night. Good night. Um okay, cool. What do people want to see next? Because I really want to do I want to do as much as I can. We've got about an hour and a half left. I will honor the last hour and a half. So I've showed you how to load a palette in. Should we try the disk stuff? Maybe we should try the disk stuff. See if that's working. So let me close this so it actually runs on the real Mega65. Okay. So as I said before, you can only load um, into X emulator up to 64 kilobytes. Beyond 64 kilobytes, the PRG it just won't load the PRG. I think it's something that LGB might be changing at some point because it has been requested by a few people to have like an ejector RAM feature that we're used to having in Vice, and certainly it will work on the real machine. So if you want to load something past the 64 kilobyte, it will work on the real machine, but you have to accept that there's certain areas of that will be non-writable. There's certain areas of that will be uh, kind of overwritten during startup, so it doesn't always kind of work. But for quick testing, it's kind of all right. But what we're going to do now is we're going to try and use the floppy IO system. So I wrote a macro called floppy IO. I think I shared it with you right at the beginning, but I will share it again just in case I didn't. Um, I've got another repo called Mega65 Toolkit. This is where the framework will be going in eventually. Oh, what's happened to the overlay? Man, what happened to the overlay? Hang on. My God. What the hell is going on today? I'm so sick of this. Okay, that's I don't know what's going on there. Yeah. There you go. That looks fine. I just honestly, honestly, I just want to go to sleep and stay asleep for ages. Uh oh, thank you for the follow, Subertis123. Very much appreciated. Welcome to the stream. Welcome to the the car crash that is this tonight's stream. Uh if it can go wrong, it will go wrong tonight. Okay, let me go back to here. So this is my Mega65 toolkit. This is what's going to contain all the code I've been doing on Perseus. For now, the only thing in there is the floppy IO code, but we will import that and we will use this floppy IO code. It's very easy to use. But first of all, we just need to go back to our batch file and get the emulator to work with disks again. So I will leave these in here, and we're going to write some new files to the disk. So first of all, we're going to write uh, what files we've got? We've got chars.bin, and we're going to call that chars, and we're going to write. So these are the files we exported from ASAPRite, and we're now writing them into a D81 file. So the other one was pal.bin, and we're going to load that in at. We're going to call that pal. Uh, and we'll try and load these now from disk. So first of all, the very first thing we're going to do is we're going to import just before the entry. Actually, we're going to import the floppy code. Now you can't import it up here. It has to be after your main code here, because it's not a macro. It's an actual floppy system. So you need to it has code that it needs to run. So you need to import it somewhere in your kind of code memory, like so. And that's pretty much all you need to do. Then to make it work, you just do floppy load, and it's that simple. So floppy load, you put this probably up at your beginning here somewhere. We'll do floppy load. Actually, we'll do it after we've set things up. We'll do it here, I think. So we do floppy load, and we give it an address. So this is our target address. So our characters we want to put at where was it? 8,000, and our palette will put it 7,000. But now what we can do is we can actually move these, right? So before we couldn't use this area of memory. So now we're gonna move the characters up to there. That's actually screen memory, so we can't use that. So we'll use 2,000. So this is what normally where the C65 ROM is. Um, so you'll see if I try and load this now. Let me just turn off that macro. If I try and load this now, we're going to get an error from Xemu. Oh well, it will do if I don't. Oh, God damn it! I forget it doesn't do the load properly, does it? So that's something I should have told LGB actually. Never mind. I don't know if he's still here. Are you still here, LGB? I guess not. What? No, it's all right. It's a minor thing. I can let him know after the stream. It's just that the auto start on uh why is he doing that now? God damn it. The auto start on disk loading doesn't work for some reason. It's oh God, I'm just not having. Oh, it's because that screen's on next to me. That's why. Turn that off. So it's memory. Okay, this is probably the same problem because this is too big. So that's why we're getting an out of memory error. If I turn this off, we won't get that problem. Um, now what's it doing? So yeah, now if I load main, it should load perfectly. When I run, we won't see anything because the characters are wrong. So first of all, let's try and load the character set into here. It also means we need to change this index. So instead of 0 to 100, uh, it would be 0 800 because that's where this is in memory. So the character is now 0 800. So let's go and change that in our character fill, which is here. So 0808 will give us that the same character. And now we can load in we'll just load the chars in for now. We'll leave the palette where it is. So we load this in at 2000 and the char name is chars. I think that's what I called it, right? Chars. I think it has to be capital. If you put it in lowercase here, it's capitals in here because of the way the fonts work on the disk. So even though we're lowercase in a batch file or a script file, here will translate to uppercase fonts in Petsky font on the disk on the disk image. You can see that if we go and have a look at the D81. So let me just find a folder. No, not find a folder. Open folder at this location, which I don't have. Really? Okay. Fuck's sake. God, I'm so angry tonight now. So angry with things. God damn it. Takes quite a lot to get me angry, but I'm kind of a bit pissed off tonight. So here's our D81, and you can see it's written the D81, but we've got main at the top in capitals. It's all in capitals. So even though we use lowercase here, it's uppercase when it comes to actually reading it. So that means on this side, when you write, you need to use uppercase. So if we do that now, hopefully that should load the characters in. If this works, it might not work in the emulator, so I don't know for sure. I think it should do though. I want to say that has worked, but I'm not 100% sure. Just check it on the real machine. See if we get the same. It looks like something loaded in. It's definitely different to what we were getting before. Okay, it looks completely different, doesn't it? Okay, maybe the floppy thing is not the right thing to do right now, but it should work though. I'm pretty sure this is what Magic Eric is using as well to similar system to do his thing. So palette data is loaded in fine. Hey, well done on that. You're figuring them out. I'm starting to think you've got access to my folder for some reason. Did I load both files? No, I just load the character set, but I already have the palette here, so it shouldn't matter. Let me just try that. Let's see if we get green characters on screen. It could be the location I'm loading it in as well. Maybe I've not. Maybe it's just a bad location. Let me just load it in somewhere else. Let me load it there and change this to 06 because I don't trust myself anymore. I'm just. Okay, screw the floppy. Screw the floppy. It's one for another time. I cannot be asked trying to figure that out now. I've got no patience at all. So if anybody's got anything for me to look at for the last hour, let me know and we'll go through that. But for now, you'll just have to deal with 64 kilobytes for now. Should be enough for anybody, right? It's not though. It's not in full color character mode. Uh, so just let me know if there's anything else you want me to look at. I will do that. And now it's loading from there. So turn those off. Great. Right. Disk. Floppy IO definitely works because I'm using it on Perseus, I'm using it on Turek, and I'm using it on everything. Is there a bitmap mode? I believe so. I think that might be what Magic Egg is using. I've not actually tried it myself though, so it could be one to try. But soon as I've not had very good luck with trying things I've not tried yet, let's not do that tonight. Let's do that another night. Oh, let's talk about the borders. So far you've seen the C64 as a machine that yeah, I think it does that a bit that way. You've seen the C64 as a machine that can kind of hardware scroll 8 pixels in either direction, and that has borders, right? And you scroll into the borders. Now with the C64, you need to do some trickery to remove the borders, but on the Mega 65, it is really simple. So there is some values in memory, which is find where it is. D048 and D048. So that is top border position and bottom border position, and there should also be a left and right one as well. But let's do the top and bottom border first. It's the top. Where's the side borders? Can't find the side borders. Let's do the top and bottom borders first anyway. So D048. So again, I have no idea if this is going to work in the emulator, but let's give it a try anyway. So let's put it in the setup Vic stuff, and let's load the accumulator with 0 and store that in D048. Good night, Jamie. Yeah, there you go. It's worked. So you can see that the top border has been removed because I set the border to begin at position 0. So this is reposition start of border of top border, and likewise you can do the same with the bottom border as well. Now this value does actually leak over into D049 as well, because it's more than good night Microman as well. It's more than 8 bits because you have 2 raster lines per line, and you can also have 50 column mode, so it uses 12 bits actually to do these values, but usually you can get away with just using the bottom one on the top border, but on the bottom border you will need to use both. Start of bottom border. So you'll see what happens if I just try and position one part of it here. So the bottom border is D04A, so MK points for steps. Reposition is spelt wrong. Do you know what though? I gave Andy points for that the other day. So as soon as I don't think you're on the board yet, are you? If you're not on the board, then fine. I'll give you some starter points. There you go. So you should be on the list now. I mean, it's dubious, but I will allow it because I did give Andy some the other day. So, oh, what's that one? Did somebody type that in, or was it discovered, or what? Oh, it was a BG Airwolf. Okay, cool. There you go. D031 is missing. Yeah, that's asking a bit much. uh, okay. What was I doing? I forgot what I was doing now. Start at the bottom border. Yeah, okay. D04A. So this is D04A. But this is going to be a bit weird because it's actually a 12-bit value. So let's just set 0 in D0 for B, and we can see where that is actually on the screen. You'll see it won't be near the bottom. It'll be somewhere up here. So it's FF is about here, right? Which kind of makes sense if you think about it, because the entire screen is usually 200 high, 200 and just over 240 to the bottom border, actually on the C64. But we're using two raster lines per line. So actually, FF is actually only here. So in order to get that all the way down to the bottom of the screen, we need to at least double it. So we need to up that top one there, and you'll see that still isn't to the bottom. There's still a little gap here. So then we need to just increase it just a little bit more. And you can see we can get rid of the bottom border like that. So that's all very well, right? And you will be able to see sprites if we go through there. Likewise, if you set the border color, the background color, you'll see the background color changing here. But that's not very good if you want the map to expand. But this is where the cool thing is: we can actually extend the map as well. So there is another setting which is called the char gen position or something. Hang on, let me work out where this is now. Can never remember which one this is. Character generate text X pos and text Y pos. Character generate a vertical position. So this is actually the value in between. So D04E and D04F. So reposition start of screen at top. So now what we're doing is we're not only we moving the border, but we're gonna actually change where the screen begins to draw its rows. So we're gonna do the same value that we've got here, but we're gonna put it into D04E, which is our text Y position. And what you'll see now is we'll move the entire screen up. And you see the screen is now it's moved up to the top here, and we've now got blank rows all the way down here. And this is because we're only showing 25 lines, right? So what you can also do is you can also say, I want you to display more rows. Find where that one is. Where is that one actually? Where is it? Border position. I can't remember which one it is now. Number of text rows to display. Okay, that is D07B. Okay. So it will be 25 to begin with. So let's increase it to let's just add 3 more rows on for now, and you'll see what we'll need to do. So we're going to add we're going up to 28 rows. But we don't see anything. Why don't we see anything? Well, the reason is because when we cleared the screen, we only cleared 25 rows. So a good idea now is to put a label up here. And we'll make that 1C there. And then we can use that in this like so, and like so. And then it's still not displaying more rows. Why is it not displaying more rows? What have I missed here? Should be able to display more rows. So in Raiden, what I did is I knocked out the borders and added more in. So huh. Okay, well let's just make it ridiculous. Let's make it like 20. That's actually done. I think that might have actually done more. Yeah, let's do 30. No, it hasn't done more, has it? Okay. Let's change that up here instead. Okay, it hasn't added any more rows in. Why isn't it adding more rows in? We should be able to change how many rows it is. Number of characters to display per row. It's not that one. It's definitely the number one. Maybe it's not supported actually. Maybe it's not supported. Okay, let's check that out by make sure we call this again on the real machine. Although it looks completely blank at the moment. I don't know why it's looking blank because it really shouldn't be looking blank. Porting the palette correctly. Oh, let's get rid of the floppy code. We don't need that anymore. Shame to even have used that now. Okay, char index is 0200 at this point. 0200, yeah. So we see it on here. And when I close this, we do get a load on here. We get a weird blank. Oh, I think this is. Hang on. This might be to do with the borders again. Let me just turn the border changes off. So on Raiden, what I did was I knocked out the top and bottom border, and that allowed me to have more space because it's kind of a vertical shooter. So it's usually it played in portrait on the in the arcade. Um, so okay, that's fine. Maybe I moved it up too far. I might have moved it too far up. See what happens when I do this now. As long as I see something in the real machine. Yeah, okay. I mean the colors are completely off for some reason. For some reason it's not using the right palettes at all in here. I think that's to do with this here. I think we said on the last one we have some issues with the palette that gets mapped. Um, so yeah, that's what we're seeing on the real machine. But I think now we'll see the right thing on this machine. Good night, Skunk Monkey. Thanks for joining. Again, apologies if the stream was not quite up to the normal standards. Yeah, okay. So there is an issue with the palettes. That's absolutely fine. We'll just go with the oops. We'll just go with the palettes that was using before. So because you have to kind of use this number to make the palette work on the emulator. But I do believe that the border positioning screws things up a little bit on the real machine as well. So I need to get it working on the real machine, and then we'll see. So that works fine. Although you can see, look, the characters are now completely different. They completely break at this point. So let's just try moving it down a little bit. Still broken. Okay. On the real machine. Okay. Maybe moving the borders is not a good one as well. This is kind of hard because I don't want to give you too many false avenues to go down. So maybe this is more of a kind of you watch me fuck things up and then just don't repeat my mistakes. Basically, don't try and do the things I'm trying to do that don't work. So um, just try repeating these. Oh, it's a lot less broken than basic. A lot less broken than basic for sure. Um, I mean, it's. I mean, it's essentially just running assembly language, right? There's just some things in the Vic implementation that aren't quite there yet, which you still have in basic, right? You still have the same missing things in the Vic implementation, but then on top of that, you have all the original bugs from the C65 ROM as well. So you have tons and tons of stuff wrong. So okay, that seems to be working on both. I think it's the reposition at the start of the screen. So let's change where this starts. Let's do it there. Okay, that's good. So I can probably nudge that up another the two. See how that runs on the real Mega while this one loads up. Okay, that's kind of all right. I mean, it's way further up the screen than it is, although that could just be down due to the capture that I've got, and also there's a bit of flickering on that blue for some reason. But there you go. This is what it looks like if I move it up to 1, 0. Let's try increasing the number of rows now. See what we get. It looks like we've got a crash actually on the Mega 65. Oh no, there we go. I still want to know why it's not drawing more rows. That's a bit weird. Oh, it is on the real machine. You see how it's drawing extra rows at the bottom now? Okay, so you can remove the borders, but you can't draw the extra rows. It will only draw the 25 rows. This is an emulator limitation as well, unfortunately. But again, you know, removing the borders is a nice to have, but not a necessity, I guess. So so you can see there the difference. So this is the emulator. It stops drawing once it's reached the last row, but on the real machine, you can actually draw extra rows at the bottom here. Um, so just avoid doing that. Okay, let's talk quickly. We've got about another hour left, so let's talk briefly about controls as well. So this is something I think Prince Faye's asked me about. Um, Joystick controls work exactly the same as a C64. You have the exact same registers that do exactly the same things. Same as the keyboard as well. Actually, the keyboard has exactly the same thing. So if you just want to go down the basic route, you can do that. However, there are some interesting additional registers, which I'm just trying to find now. Um, is that it? Yeah, this one. So let's again, I don't know if these are going to work in the emulator. So again, this is kind of a crazy thing. So I'm going to get rid of these, well, the number of rows because that's not actually working. But I'll leave these ones in, but I'll comment them out because they're not something you'd probably want to turn on. But did you fix the second button issue with the monster? No, no. I think it's I need to get an original C64 set up again. I've got a couple of boards. I just need to fix them. Um, but yeah, I think it might be FPGA versions of the SID um, have a problem with the analog because the the second button uses the analog, right? So it presses it pulls the pot X low or it pulls it high. I can't remember which one it is, but I think it pulls it low. Um, no, actually, it must. I don't know. It doesn't matter either way. But I think the problem is it uses the real C64 uses the SID to do that, and FPGAs don't have that analog component in it, so they have to emulate that. And I think most of the emulations actually have it flipped the other way. So instead of pulling it low, it pulls it high, or vice versa, whichever way it is. So it means that the second button is always jumping, and that seems to be the problem I have with both the Ultimate 64 and the Mega 65. I need to do a bit more testing, but I need to get an original C64 set up to do that test because until I do that, I can't really report if it's the same on both. It could very well be the joystick, but the thing that they have in common is that they're both FPGA SIDs, aren't they? So, well, actually, it's a good point. Am I using the FPGA SID on? Ah, no, I should be using real SIDs on the Ultimate. So I'm not sure why that would be. Ah, actually, that's a good point. Maybe it's the joystick then. I don't know why it would be the joystick. It shouldn't be. I mean, it's hard to set it up wrong, but I'll double check it at some point. Uh, I'm not worrying too much about that right now because I want to try and build the Perseus game without the need for a second button if I can help it. or at the very least, space bar, kind of like Turrican, space bar stroke button two. So if you have got button two set up, use it. Otherwise, it's space bar. Um, but with configurable things, you'd be able to play it on keyboard as well, and maybe even mouse. I don't know yet. Um, oh God, hang on, I've got the message. All right, I might have to end early, guys. um, Usually up to jump for single button games. Yeah, I mean it will be. I think Perseus will be up to jump. Um, uh, guys, I think I'm gonna have to. I think I'm gonna have to stop early. Sorry. Oh, Jesus Christ. All right. Really sorry. Thank you for putting up with this stream. It's not been the easiest one. I'm just gonna go and find someone to raid. In fact, is a revision back on? We can just go and raid them if they're on. I bet they're not though, are they? So I think they got banned, didn't they? So why I don't know, but uh, yeah, they got banned, didn't they? Fucking hell. All right, let's go and raid Duke. All right, sorry guys. It's just it's been one of those days today, and it's kind of come through in the coding as well. So apologies that the stream wasn't quite as informative as it should have been. I'm glad you found it interesting. Thank you. We'll try and we'll try and make up for it through the week. We'll be back on the Game Boy stuff on Tuesday. We'll be doing some code. Um, Hopefully, we'll have some a nice announcement around that as well. Tuesday, Wednesday ish. Um, but yeah, thanks for joining, guys. Again, seriously, apologies for the kind of low quality of the stream. Really not up to my normal standards. So we'll make up for it through the week. I promise. Thank you for all the subs, all the cheers, all the support, and thank you for coming along tonight. Cheerio. See you soon.